Beatles 28, you are clear for takeoff.
Knots. Stop! Don't hammer the brakes. Don't hammer the brakes.
137 people are on board this British Air Tours flight. Within minutes, nearly half of them will be dead.
This should not really have happened.
Evacuate! Evacuate!
The aircraft didn't even get airborne. It didn't run off the runway, and yet still 55 people were killed.
For investigators, it's a familiar routine. Reconstructing the final moments inside the cabin, analyzing the wreckage and the flight data recorders. In the end, they turn to a psychologist to help them figure out how a survivable emergency turned into one of British aviation's most horrific disasters. It's just before 6 in the morning on August the 22nd, 1985. Manchester's airport is coming to life. The first flights of the day are being prepped for departure. British Air Tours Flight 28 is scheduled to take 131 passengers from Manchester to the Greek island of Corfu. British Air Tours is a division of British Airways, specializing in low-cost flights to vacation destinations. It's a chilly morning. A slight breeze is blowing, ideal flying weather. Most of the passengers on this early morning flight are traveling on vacation. Lindsay Davis is heading to Greece with her boyfriend, Charlie Thixon.
All right, let's go.
We'd been going out with each other for a year, and that's one of the reasons we were so excited about it. You know, it was our first holiday together.
Captain Peter Terrington is in command.
I was the senior training captain on the fleet.
First Officer Brian Love is being trained by Terrington.
He was going to perform the takeoff and landing as part of his training.
All right, Captain? Yep. Briefing then, Brian. Airfield emergencies, you handling the aircraft. What are the 4 things you're going to stop for?
Fire, failure, configuration warning, or you shouting stop.
Okay, so you bring the thing to a stop, and I'll take over the aircraft and leave you to deal with the emergency. I'll liaise with ATC, okay?
If you've talked about the possibility of an emergency and talked over what you will do, then if it actually happens, it's easier to recall those items.
Okay, Brian, start 2.
Starting 2. Oil pressure rising.
Okay, go on.
25, 26, 27, 28, 29. 129 plus 2 on board, Captain. All strapped in, doors are closed and automatic.
Thank you, Arthur.
The crew is flying a Boeing 737. It takes just 4 minutes for the plane to reach the foot of the runway.
Beatles 28, you are clear for takeoff.
The 737 has 3,000 meters to get to takeoff speed. The engines are pushed to high power.
I was sitting by the window, looking out of the window. Everything was normal. The plane was going quite fast.
80 knots.
Check.
We heard a dull thud, which sounded as if it came from outside. I was really keen to see what was going on outside, but couldn't see anything.
Captain Terrington needs to act fast.
Stop!
And the immediate reaction was to stop. We were quite a few knots below our decision speed, so I very quickly closed the throttles and applied reverse thrust.
We could feel the aircraft slowing down, and Arthur said, "Oh, I think we've blown a tyre," and I didn't know, so we just waited to hear it.
Don't hammer the brakes. Don't hammer the brakes.
I thought the tyre might have gone and would cause damage to the undercarriage if we braked too strongly.
Probably nothing. I wouldn't worry.
And just assumed that maybe a tyre had burst, so I wasn't really alarmed at that point. My thought at that time was, oh, okay, we're going to get off this plane and probably have to move all the luggage onto another plane and take off.
Soon, passengers on the left side of the plane see the real problem.
I could see orange flames inside the back of the engine. And at that point, I thought, it's obviously not a burst tyre, that wouldn't cause that, and this is perhaps something a bit more serious.
Let me by. I'm not staying there.
But at that point, I knew that I wanted to get off the plane, and I wasn't happy at all. I knew that there was a fire, and I just wanted to get away from the fire.
Smoke is seeping into the cabin.
Please sit down.
My nearest exit was at the back. I didn't want to go to the back because the smoke was coming in there. So I decided in my mind that I was going to go through the front. I said to Charlie,
On, we're going.
and that's when I started going towards the front of the plane.
Stop it. 28 Mike, we are abandoning takeoff. Looks like we've got a fire on number 1.
Looks like there's a lot of fire.
Thank you.
Plane on fire, runway 24.
From where he's sitting, Captain Terrington can't see how bad the fire is. He needs advice from the tower.
Do we have to get the passengers off?
I would do by the starboard side.
Terrington decides to pull off the runway.
Evacuate to the starboard side, please. Fire drill, engine number 1. Shutting down 2.
Evacuate! Evacuate! Please stay calm.
Before the flight crew leaves the cockpit, they must complete a 15-step checklist.
Parking brake.
Set.
Speed brake lever.
Down.
But time is running out.
We had an evacuation checklist, but it was 4 pages long, and the last item was to get the passengers off.
Engine and APU fire warning switches.
This didn't cover my problem at all.
On the 737, there are 4 cabin doors. The 2 in the back are covered in flames and smoke, leaving only 2 for 137 people. Then, a mechanical problem eliminates one of those.
Well, Arthur was opening one right, and it was really trying to open. It was really hard to open.
The back of the cabin is filling with smoke. It's making breathing difficult. Passengers rush forward.
It just seemed to go on forever before they started evacuating. And that's when I thought, I'm not going to get on, it's going to blow up with all of us on it.
Engine and APU fire warning switches.
Right now, all 137 people on board are alive. But with every second, their odds of surviving are decreasing. Flight 28 is becoming a death trap. The jammed door on the right side of British Air Tours Flight 28 leaves the crew no choice. They must get the passengers out from the side of the plane that's burning.
There's soon as we opened the door, the fire service were already around, shooting foam up the slide and came into the galley floor. We wanted to start to evacuate the passengers, but there's a bit of a bottleneck and nobody was coming forward. The aisle is quite narrow where the galley is, and they were and then they were pushing forward, and I could see this boy that was really sort of pushed against the wall. He couldn't get out, so I pulled him by his T-shirt, had the yellow T-shirt on, and he sort of tumbled forward, and after that, everybody sort of just tumbled in behind him. And we just directed him down the slide. In training, they tell you to, bring people to the door and you tell them to jump.
Desperate to get people off the plane quickly, the purser returns to the jammed door. After several attempts, he manages to force it open.
The only time I turned around was to make sure that Charlie was following me.
See you out there.
One thing I did see when I looked back was people going to the front, towards the front of the plane where the seats are, and pushing the seats forward, folding them down as they went along. So people were trying to rush forward from the back. The chute was open and people were just jumping up straight onto the chute. As I got to the bottom, didn't look back at all, was just wanting to get off.
Dozens of passengers have made it off the plane, but there are still many more inside.
But it was smouldering and it was black, thick black smoke. And Charlie had said that after you'd gone, this black smoke came down, he said, and everybody was screaming and panicking. He said people are going to die in there.
Standby power switch.
Captain Peter Terrington and his first officer, Brian Love, are still aboard the burning airplane, and they still haven't completed the steps required to evacuate.
There was 4 tons of fuel coming out of that aircraft wing tank.
Here, go, Brian. Go, Brian.
I could see quite a lot of flames.
Completing the checklist would put their lives at risk.
We did as many items as we could, and then we both went out of the flight deck window.
There are no more passengers at the exits, so Joanna Toff decides to see if anyone else is left in the cabin.
And the smoke was you could touch it. It was so thick, and you could take it was awful, really.
Go.
There was a young girl just a bit further down in the cabin, but she was really disorientated. I mean, I suppose we all were, really. We just didn't have any idea what was going on. I just brought her down to the slide. She was taken off then. The fireman was telling me to come, and I was thinking, well, I've not finished, we've not finished yet.
When Toff re-enters the cabin, the thick smoke makes it as hard to see as it is to breathe.
It was really dark and quiet. I'd never seen anything like it. And I could see the light from the door anyway by then, so I knew where the door was.
The smoke forces Toff to abandon her search. Just minutes after pulling off the runway, British Air Tours Flight 28 has been consumed by fire.
We got out of a flight deck which was relatively intact, and when we turned round on the ground, we saw a complete wreck of an aircraft, and it had happened in a matter of seconds. It was dreadful.
54 people are dead. Another would die in hospital.
There was nothing wrong, really, with us. We thought nothing physical wrong with us. But our lives changed, you know, just in those few hours.
I couldn't breathe. I was virtually out the door, and I couldn't breathe then.
The smoke was coming in and everybody just stood up and ran out. It was just a mad panic getting out.
Because when the smoke came, you just couldn't see anything at all. Couldn't see anybody.
It takes 125 firefighters more than 2 hours to put out the fire. News of the disaster soon spreads around the world. British Prime Minister Margaret Thatcher flies to Manchester to visit the scene.
When we get a terrible air crash of this kind, everyone is appalled and shocked. Every single aspect of this accident will be thoroughly investigated. It has to be.
This is the 4th major commercial air disaster of the year. In June of 1985, an Air India jet exploded over the Atlantic Ocean. 329 people were killed. Weeks later, 137 people died when a Delta Airlines flight crashed at Dallas-Fort Worth Airport. And just 10 days before the Manchester crash, the deadliest single aircraft accident in history. Japan Airlines Flight 123, a fully loaded 747, slammed into a mountain, killing 520 people. British Air Tours Flight 28 adds 55 new victims to the list of casualties. 1985 is now the deadliest year in the history of commercial aviation. The flying public is getting nervous. Britain's Air Accidents Investigation Branch sends a team to Manchester to unravel the events that led to the catastrophe. Among them, Stephen Moss. He'll be inspecting the plane's engines.
This should not really have happened. The aircraft didn't even get airborne. It didn't run off the runway, and yet still 55 people were killed.
Chris Prothero is also on the team. His focus is on the fire.
We were aware from initial reports that the fire had entered the aircraft very rapidly as the aircraft came to a halt, and that was a focus for me.
It doesn't take too long for Stephen Moss to figure out where the trouble started. He sees damage to the plane that was not caused by fire.
Well, the first thing we noticed clearly was the hole in the underside of the wing. And right next to it was a gaping hole in the side of the engine. It seems that one had led to the other.
To get a plane loaded with passengers off the ground, you need to generate massive thrust. That power is created when air travels through the front of the engine to a series of compressor fans. It's then ignited, and the exhaust pushes the plane forward. Something had clearly gone very wrong with Flight 28's left engine. Investigators look for clues on the runway and in the cabin, hoping to discover why so many people died.
Entering the cabin for the first time, there was as with all aircraft fires, there's an overwhelming and pungent smell. Burning plastic, burnt fuel, burning material had dropped down onto seats, and so the aisles were filled up with the remains of overhead lockers. A scene of devastation.
The damage in the cabin is revealing. It's almost completely charred up high, but is relatively intact down low.
It was clear that there had not been flashover in this particular case.
A flashover occurs when the gases in an enclosed space become so hot that they ignite, incinerating everything around them. The way Flight 28's cabin is charred tells Prothero about the nature of the fire.
Many of the seats squab, cushions, even things like the emergency evacuation cards, which are just plastic laminated cards, were pretty much undamaged. You could have wiped them off and put them on another aircraft and nobody would have known they'd been in this accident, whereas at the upper levels in the fuselage, there was a great deal of heat damage, and this is not a characteristic of a flashover.
The fire in the cabin had been severe, but should not have been catastrophic. This leaves investigators with two questions. Why did so many people die? And what caused the fire? The answer to the second question may be outside the plane, lying on the runway. Investigators find a large piece of dome-shaped metal along the plane's path. Stephen Moss can see it's from a piece of the engine called a combustor can.
It looks like there'd been a separation of the can from the front end from the back end.
The combustion chamber of the 737's jet engines contains 9 combustor cans. It's where fuel and air are mixed and ignited, so each can needs to withstand intense heat. Moss suspects the fractured can somehow blew apart and destroyed the plane's left engine.
It had struck an underwing fuel tank access panel and put a sizable hole in that, which directly led to the release of a vast quantity of fuel.
Proving the piece of the combustion can penetrated the wing is easy. It fits neatly into the hole in the wing.
This was clearly, if you like, the root cause of the accident.
The engine on the plane is a Pratt & Whitney JT8D. For Moss, that's of grave concern.
At the time, was probably the most widely used jet engine on commercial air transport in the world. And it was obviously pretty urgent that we try and find the cause of this one in order to prevent other aircraft having the same problem.
There are tens of thousands of combustor cans in service around the world. One of them erupted in Manchester. Stephen Moss needs to find out why it failed. And fast. Investigators looking into the deadly fire on board British Air Tours Flight 28 study the plane's maintenance log. They discover the combustor can that ruptured had previously been repaired.
We needed to look at that repair and how effective it was.
During a routine inspection a year and a half earlier, mechanics had found small cracks in some of the combustor cans.
It was certainly not uncommon to find fatigue cracks in the cans. They're operating in a high-temperature environment. The manuals give various schemes for repairing these cracks.
Investigators find mechanics repaired the cracks according to a procedure laid out in the engine repair manual. They welded them closed. But the crack on can number 9 was unusually long.
The overhaul manual did not give any limit on the length of crack that could be repaired, and it was a longer crack than had been experienced before. It was still repaired.
After the repaired cans were put back in the engine, mechanics had no way of knowing the weld didn't effectively seal the crack. That's because the cans can't be inspected while the engine is on the plane. Since the repair, there were 11 reports of slow acceleration from the engine that exploded in Manchester. A damaged combustor can could have been a reason for the problem. But troubleshooting guides available to mechanics in Manchester didn't list that as a potential cause. Instead, Pratt & Whitney offered other ways to fix the acceleration problem.
It didn't seem to ring any great alarm bells with them, if you like. They'd seen it before, and it had never turned out to be anything serious.
So mechanics in Manchester made minor adjustments to fix the plane's idle speed and kept the plane in operation. Cockpit voice recordings reveal that the crew of Flight 28 was aware there was a problem with slow acceleration.
Slow acceleration on number 1 engine the day before yesterday.
I was on the flight, yes, sir.
Engineers signed off on it.
But the log entry led Captain Terrington to believe that the problem had been fixed.
A comment in the TET log for the flight before the last one, that the engine was slow in accelerating. It wasn't apparent as a serious problem because the engineers had done some work and the aircraft had been flying the previous day with no problems.
The idle speed adjustments didn't fix the real problem, the cracked combustor can. And it reached the breaking point on Flight 28.
Stopping. 28 Mike, we are abandoning takeoff.
Evacuate! Evacuate! Please stay calm and don't panic.
If the airline had inspected the cans, I think there is no doubt that they would have seen the problem.
Investigators now know the origins of the Manchester disaster. The welded crack in combustor can number 9 gave way as Flight 28 sped down the runway. The front of the can was ejected from the engine and put a hole in the underside of the left wing. That led to a huge fuel leak onto the damaged engine, which caused the fire. Engine fires are not uncommon. The body of a 737 is insulated with fire-retardant material to protect the cabin. Investigators still don't understand how a fire outside the plane spread into the cabin as quickly as it did. Fire Inspector Chris Prothero finds part of the answer from viewing photographs of the plane as it sped down the runway.
It was clear from these photographs that there was a very dynamic phase to the fire whilst the aircraft was at speed on the runway, which produced this energetic, turbulent, sort of blowtorching type of fire, visually anyway, trailing behind the aircraft.
A press photo from the day of the crash leads Prothero to a new theory.
The photographs of the aircraft that appeared in the press showed the left thrust reverser deployed. The general impression that one got visually from that photograph was that the thrust reversers had effectively blowtorched fire against the side of the fuselage, and that, if you like, was the explanation as to why the fire had penetrated so quickly. That photograph and the implications of it actually, therefore, loomed quite large.
Stop!
There are several ways to bring a speeding jetliner to a halt. One is with the brakes.
Don't hammer the brakes.
Another is with the engine's thrust reversers. Thrust reversers redirect the exhaust from the jet engine forwards. This helps slow the plane down.
It looked as though the thrust reversers had simply blown this big fire on the left of the aircraft directly onto the side of the aircraft, directly onto the rear fuselage.
That would explain why the fire destroyed the cabin so quickly. It now seems possible that Captain Terrington made the fire worse by trying to slow his plane down. But Prothero has two good reasons to doubt his theory. One is the location where charring from the burning exhaust gas, or efflux, was found.
The efflux impinges on the fuselage further up, closer to the roof, the crown skins of the aircraft. So actually, the penetration that we had low down did not fit with that.
And the other reason is, by the time the thrust reversers were deployed, the left engine had already exploded. But to act as a blowtorch, the engine would have needed considerable exhaust.
We did calculations to confirm that the residual thrust from that engine would not have had the energy to have this effect. That confirmed that the thrust reversers couldn't actually have played any role, or significant role anyway, in the fire's severity.
Clearly, something other than the thrusters had caused the fire to spread so quickly. Prothero looks more closely at the data. After examining weather reports from the day of the accident, he finds the answer.
The wind was the main factor that determined the severity of the fire in terms of its attack on the outside of the aircraft, how rapidly it penetrated the aircraft, and it also affected the conditions inside the cabin.
Believing he had blown a tire, Captain Terrington made a fateful decision.
Stopping. 28 Mike, we are abandoning takeoff.
Well, when we heard the thud and we closed the throttles, it was my assumption that we were going to turn off the runway, clear the runway, ask air traffic for an engineer to come out and check the tyres.
Like a highway, an airport runway has a series of exits. Captain Terrington chose one called Link Delta.
So we've got a fire on number 1.
When we got the additional information of a fire warning, the brain was already programmed to carry out the stop.
The crew had been aware that they had a fire, but didn't really appreciate at the time the nature of the fire, the severity of the fire, so they had turned off the runway.
Captain Terrington turned his plane to the right and brought it to a stop. He couldn't have realized that doing so would make the problem far worse.
There was a crosswind, a slight crosswind, from the left side of the aircraft that was carrying the fire that was burning from the fuel that was pulled underneath the left wing. It carried that fire aft, rearwards, and took over and under the rear fuselage, in between the wing and the tailplane.
The wind wrapped the fire around the back of the plane and into the cabin.
If there'd been no wind at all, I think the situation would have been very much more benign.
Investigators have discovered how the fire started and the conditions that caused it to penetrate the cabin. Now investigator Ed Trimble must solve the biggest mystery surrounding the Manchester accident.
Here we had an aircraft which had aborted the takeoff for good reason. It had taxied off and stopped in a taxiway in an expeditious manner, and yet 55 people had lost their lives. So there was a big question as to precisely why that had occurred.
Investigators learned that most of the dead were not found in the worst burned parts of the plane. Autopsies will point to the real killer on Flight 28. Of the 54 people who died in the cabin, only 6 had suffered serious burns. All the rest died from smoke inhalation. It seems the smoke in the cabin was particularly lethal. Survivors tell investigators that the smoke was unbearable.
The smoke was really black, and it was almost touching you. It was really weird.
And they say the effect of that was shocking. Immediately you took one breath of the smoke, you began to feel debilitated, and you knew that if you took another breath or two, you weren't going to make it.
At the time of the Manchester accident, the effects of fire on an airplane had been well studied and understood, but the effects of smoke were not. To figure out what made the smoke so toxic, Trimble decides to recreate the fire that burned on Flight 28.
We were trying to model not only the gases which were produced, but also the kind of threat levels which were produced.
The smoke that filled the plane was from materials burning inside the cabin. The foam in the seats, the wool in the carpets, and the plastic overhead bins all release poisonous fumes. Those conditions are recreated by burning those same materials. Trimble discovers the passengers on Flight 28 inhaled smoke that contained a deadly blend of poisonous gases, including high levels of carbon monoxide and hydrogen cyanide. Now he desperately needs to find out if there's any way to protect airline passengers from that kind of smoke.
So it seemed to me pretty clear that unless we could protect people's respiratory systems from the assault from such combustion gases, there was little that we could do to improve survival chances from aircraft fires.
Over the course of 5 weeks, investigators run dozens of tests, experimenting with different filters. They burn nearly a quarter ton of material to create the necessary smoke. Their dramatic conclusion: it may have been possible to save passengers' lives.
There was not the slightest doubt in my mind that in these situations, in an aircraft cabin, if it is being assaulted by combustion gases, your chances of survival are vastly improved if you have smoke hood protection.
British Air Tours Flight 28 had only enough smoke hoods for the crew. They were never used. Trimble's research indicates that smoke hoods for passengers could have saved lives.
There were hoods available, both of the filter type and the breathable gas type, which can provide a very high level of protection to people in these circumstances.
Many of the passengers on Flight 28 would have survived with a few more minutes of breathing time.
It was in a blink of an eye, you know, from the time, you know, we stopped on the runway, you know, just within a few minutes, you know, it was all over, really.
A full Boeing 737 is designed to be evacuated in less than 2 minutes. So even without additional time, more of the passengers on Flight 28 should have been able to get off. To discover why so many people never made it off the plane, investigators turned to an unlikely source for the answer. By law, airplane manufacturers must prove their planes can be evacuated quickly and safely. When the 737 was introduced in the UK, Boeing demonstrated that 130 people could get off the plane in just 75 seconds.
All public transport aircraft are certificated to the same criteria, and that is that the total complement of passengers must be capable of evacuating from the aircraft using half the exits in the aircraft, generally one side or the other, within a maximum of 90 seconds.
But 90 seconds after Flight 28 came to a stop, most of the passengers were still on board.
The reason why the evacuation in Manchester wasn't achieved in 90 seconds is because the conditions in a real fire evacuation are completely different from the certification conditions.
The certification evacuation is conducted in clear conditions, with no smoke that reduces vision and overwhelms passengers. Within minutes of coming to a stop, Flight 28 filled with thick black smoke.
As soon as the smoke began to spill into the rear cabin and then flow forwards, essentially that induced immediate panic in those who were so affected by the smoke, because their respiration, I mean, the typical comment was, I took one breath of smoke and I felt as though my lungs were solidifying. You can imagine under these conditions that people have got to get away from the smoke. And people did this by basically clambering over the seats and other people in front of them.
In less than 5 minutes, what should have been a survivable accident turned deadly. To prevent future tragedies, Britain's Civil Aviation Authority decides to learn more about people. Helen Muir is a psychologist and a leading expert on how airplane design can influence survival. She's asked to study the behavior of passengers on Flight 28 to figure out why so many died.
What we had to learn to do was to design the aircraft interior so even if we had what we might say was dysfunctional behaviour in totality, we could accommodate the needs of individuals and their desperate rush to get out.
Muir configures a cabin to duplicate Flight 28 and fills it with volunteers. Then, to have them act as though the plane's on fire, she offers money to the first ones off.
And that produced behaviour that was quite unbelievable. People went over seats, they went round, past each other, all sorts of things. And indeed, when survivors from the actual Manchester accident came and saw the videos, they said, yeah, that's how it was.
The evacuation of Flight 28 was slowed by the fact that passengers became jammed in the bulkhead opening separating the main cabin from the galley. Investigators discover the logjam was created by the design of the Boeing 737. The bulkhead opening was 22.5 inches wide, just enough for one person to fit through.
But what they wanted to know was how much wider would they have to make it for people not to get stopped and blocked. We were trying to do as much as we could to recreate the situation which had happened at Manchester and then to systematically vary the aircraft interior to see what changes would improve the situation for passengers.
Muir's tests showed the narrow bulkhead opening created bottlenecks that flight attendants had to constantly clear. Increasing the width to 30 inches greatly improved the movement of passengers.
But we showed through repeat testing that if you changed the minimum gap from 20 to 30 inches, you would dramatically improve the speed at which people could get out and you'd reduce the likelihood of people falling and slipping and so on.
As a result of Helen Muir's work, a recommendation was made to increase the space between the bulkhead walls to 30 inches and introduce strip lighting to help guide passengers to exits even when they are blinded by smoke. Muir also found a way to improve cabin safety without redesigning the cabin.
Please sit down.
She conducted research on the behavior of the cabin crew in emergencies and found that passengers get off a plane much faster with a highly assertive crew.
It's because we don't want people really making their own decisions. We want people to do exactly what the cabin crew or the procedures state, and we don't want people hesitating, particularly at the door.
Helen Muir's research prompted manufacturers to redesign cabins to make them safer. But one safety feature remains controversial: smoke hoods. Ed Trimble believes they should be mandatory on all commercial flights.
Without a doubt. Without a doubt.
Helen Muir is less convinced. She's studied how smoke hoods affect passenger behavior and is worried they would slow down the orderly evacuation of an airplane.
We know you've only got literally 1.5 to 2 minutes for everybody to get out. What we don't want to have is something which is difficult to put on, and so it slows people getting down.
The most important lesson of British Air Tours Flight 28 is that seconds matter. It's now universally accepted that it takes 90 seconds from the first sign of fire before it becomes unsurvivable. The passengers on Flight 28 lost valuable time when the starboard side door jammed. The investigators determined that the slide mechanism deployed too early, preventing the door from opening. There was a flaw that led the slide container's lid to jam if the door is opened too quickly. After the Manchester accident, Boeing quickly redesigned the system so that couldn't happen. But the recommendations made by the AAIB weren't adopted quickly enough to save lives 6 years later. In 1991, a Boeing 737 slammed into another plane on the runway in Los Angeles and caught fire. Many of the 22 people who died were overcome by smoke before they could get out. But in 2005, the crash of an Air France jet in Toronto showed how much has changed since the Manchester accident. All 309 people got off that plane in just 90 seconds. No one died. Some major changes to commercial airliners
All right, the door's open.
came about because of a flight that never left the ground.
And that's the only way I can resolve it, with the death of 55 of my passengers. The fact that flying is now safer.
I can't imagine anybody, you know, doesn't wish that it hadn't happened. You know, despite what's been learned and despite maybe the subsequent lives that have been changed, you know, you'd give anything for it not to have happened.
For investigators trying to solve a plane crash, the most important tool can be the black box. It records every detail in the cockpit.
Look at this. Where's Charlie at?
And tells investigators about vital conversations.
Damn, it's starting to rain.
Northwest 255, runway 3 center, clear for takeoff.
But in the crash of Northwest Airlines Flight 255...
I have never been to an accident of that scale.
It wasn't what investigators heard on the tape.
TCI was on set.
It was what they didn't hear.
It was checked.
That would lead to an astonishing conclusion. Detroit, Michigan, August the 16th, 1987. It's 8 p.m. and the city is sweltering. 25 kilometers from downtown, Detroit Metropolitan Airport is one of the busiest airports in the United States. More than 1,100 airplanes use its 4 runways each day. Today, one of those is Northwest Airlines Flight 255, bound for Phoenix, Arizona. Captain John Mouse is in command. A Las Vegas native, 57-year-old Mouse is a veteran pilot. His first officer is 35-year-old David Dodds of Galena, Illinois.
Why don't you tell them we're ready to go?
Both have years of experience on this type of aircraft. The MD-80 is also known as the Super 80 and is the second generation of the DC-9.
The MD-80 was quite a bit longer. It had more powerful engines, so it could carry more people. For that reason, it was a better moneymaker for the airlines than the DC-9 was.
Look at this.
The sky between Detroit and Phoenix is filled with storms. Several are moving quickly towards the airport.
There's a line here.
For for the crew, it's been a long day.
We're about 25 miles wide. Well, if we get out of here pretty quick, we won't have a delay.
They've already flown from Minneapolis, Minnesota, to Saginaw, Michigan, and then Detroit. Phoenix is their next stop on the way to Santa Ana, California.
If we wait till after the storm's here, there'll be delays going over Waterville.
If they're delayed by weather, they may not make their final destination.
Let's get out of here before it starts raining.
The plane's 149 passengers are also eager to leave. Paula Sheehan and her family have been visiting relatives. They're heading home to Arizona. Her daughter Cecilia is only 4 years old.
Looks like bags are all in. Why don't you tell them we're ready to go? Ram 255 and Delta 50.
Flight 255 is running half an hour late.
Northwest 255, cleared to go.
Okay, we're cleared to push.
Let's do the checklist.
Brakes.
Set.
Windshield heat. It's on. Push the pumps. Unit 6. Cabin pressure controller. Checked. Auxiliary hydraulic pumps and pressure. On and checked.
Yeah. It's starting to rain.
To beat the storms, they need to leave immediately.
Sign beacons. Go on. Before start checklist is complete.
Flight 255 begins moving from the gate to the runway.
Northwest 255.
But because of the weather...
Northwest 255, now exit at Charlie Runway 3 Center.
The ground controller gives them a last-minute runway change.
Okay, to Charlie for 3 Center, Northwest 255. Charlie for 3 Center, right.
Okay.
Ladies and gentlemen, we're currently number 1 for departure. We should be rolling in a couple minutes. Let attendants be seated, thank you.
Blacker than hell out there.
Where's Charlie at?
By the time they get to the new runway, they're 45 minutes behind schedule.
Northwest 255, runway 3 Center, clear for takeoff.
Within 17 seconds, 65,000 kilograms of passengers and aircraft hurtle down runway 3C. But moments before liftoff, Mouse discovers he can't engage the auto throttle.
Let's stay on. TCI's on set.
His computer isn't in takeoff mode.
They're on now.
Okay.
Clamp. 100 knots.
At 313 kilometers per hour.
V1. Rotate.
The pilots angle the plane's nose up for liftoff. Then something else goes wrong. Just under 50 feet from the ground, the aircraft begins rolling from side to side.
Power lifeguard copter 102.
It rolls left and strikes a light pole. Out of control, Flight 255 slams into the ground, skids along a highway, and disintegrates when it hits an overpass.
I prayed that everybody made it, but I thought it was just a small plane because it happened so quickly. I didn't know it was a bigger plane, and it was just awful.
I saw the plane come through the viaducts, a big fireball.
Well, we got dispatched. It was a rainy Sunday night. And then he said there's an airliner down, and our mood kind of just changed. And the one guy looked at me, Dan, and said, well, I hope it's a small one. When we pulled up, we saw the cockpit, and the word West written on the fuselage, and we looked at each other and he said, it looks like a big one.
There's a trail of scorched bodies and debris more than a kilometer long. Just minutes after impact, paramedic Tim Schroeder is on the scene looking for survivors.
I've never been to an accident of that scale. We were struck by the magnitude of what we were seeing, the large scale of it. It was almost overwhelming.
From the little that's left of Flight 255, it is unlikely they'll find anyone alive.
And I buddied up with Dan, and we both started entering the wreckage. It was probably a minute went by, and Dan actually heard a noise. He asked me a couple times, you know, do I hear anything? And I said no. And then finally I heard it, and it was more like a faint cry. When I turned my head to the right, I saw an arm underneath the seat.
1, 2, 3, lift!
She was covered in some blood and some soot.
Somehow, 4-year-old Cecilia Sheehan has survived the crash. But she's badly injured. Tim Schroeder races her to hospital.
We have a 4-year-old girl found alive in the wreckage. She has a very weak pulse.
If Cecilia survived, perhaps others have as well. Rescuers spend hours looking through the wreckage for more survivors, but their efforts will be in vain.
We actually covered anything that was a body or a body part with a yellow blanket. It was just nothing but like a sea of yellow blankets, basically.
Northwest Airlines said 154 passengers and crew aboard the plane died in the crash.
Both Captain Mouse and First Officer Dodds are killed in the crash. 2 other people died when their cars were hit by the plane. This is the second deadliest airplane disaster in US history. Recovering in hospital with serious head wounds is Flight 255's lone survivor, 4-year-old Cecilia Sheehan. Despite her injuries, doctors say she will live.
Maybe God was on her side that night.
Within hours of the crash, investigator Jack Drake and his team from the National Transportation Safety Board begin looking for clues. Drake is a former Navy pilot who's been involved in hundreds of crash investigations.
You know when you're at a crash site because you get this combination of burned plastic and kerosene, and sometimes combined with fire retardant foam that has its own distinctive odor. You know you've arrived when you smell it.
Drake and his team treat the crash site like a crime scene.
Our team consisted of 12 or 13 specialists, some of whom go to the site and some of whom do their work elsewhere.
They set out to examine every piece of wreckage to discover what went wrong.
They have responsibilities for looking at different parts of the wreckage debris and do qualitative analysis of those parts. We always look for the recorders first. They're frequently referred to as black boxes, although they're usually orange. The information is usually well protected because they're encased in a steel box that is both heat resistant and crash resistant.
Since the 1960s, commercial jetliners have been required to carry flight data and voice recorders. The CVR was first introduced in Australia following the 1960 crash of a Fokker F-27. The devices must be able to withstand an impact of 3,400 Gs and temperatures as high as 1,100 degrees Celsius. The cockpit voice recorder is intact, but the flight data recorder suffered some damage in the crash. They may hold the only clues that can help solve this accident. Both recorders are sent to the NTSB lab in Washington, D.C. John Clark is Drake's flight performance engineer. His first task is to make a map of the debris left behind by Flight 255.
When I first started seeing the wreckage, your mind immediately starts turning to sorting out where it hit, how it hit, not where the wreckage ended up, but those first few inches where the airplane was coming down.
Clark looks for ground scars and other impact marks, and interviews witnesses to piece together where the plane fell and how.
And that kind of gives you a sense of those last moments, what the airplane was doing when it hit the ground.
Clark begins to understand the final moments of Flight 255. According to witnesses, as it lifted off, it couldn't climb and flew in a nose-high position.
B1, rotate.
That could indicate that the plane didn't have enough power to get off the ground, that it didn't have enough speed, or that high winds prevented it from lifting off. Witnesses provide investigators with a critical clue.
You saw fire coming from the engine.
Several, including an air traffic controller, saw flames coming from the plane's engine before the crash. The engines become the first focus of this investigation.
They look for evidence of an internal failure.
The plane suffered an engine failure.
Investigators soon learned that less than a month earlier, one of the plane's engines was damaged when it was hit by a foreign object. It was repaired and was being monitored by mechanics to see how it performed. The team studies the remains of the engine for clues that it had either caught fire or shut down on takeoff. Despite what the witnesses saw, they find no evidence of fire or of a massive breakdown.
The information suggested that the engine operation had been normal.
Clamp, 100 knots.
The flames were the result of the fuel tank rupturing after the plane hit a light pole. The fire didn't cause the crash. If Drake and his team are to solve this mystery, they need to be certain about what happened in the last few seconds before Flight 255 crashed.
Well, I think probably the best physical evidence is what was on the flight data recorder. The flight data recorder doesn't tell you about weather, it tells you about aircraft parameters, aircraft performance essentially second by second, even at quarter-second intervals in some parameters.
But NTSB technicians can't recover all the information from the recorder. They send it to the manufacturer to see if they can recover the lost data. While he waits for news about the flight data recorder, Jack Drake looks more closely at the weather on the night of the crash.
There was some convective or thundershower type activity that had moved through the area, and its impact on the accident required a lot of analysis.
Drake wonders how the storm affected Flight 255. He listens to the cockpit voice recorder for clues. He discovers the menacing weather was a concern to the crew.
Let's get out of here before it starts raining.
Jesus, look at this.
Drake sees that there were several storms along the flight path, and they were getting closer to Detroit.
There's a line here, and a line between these two, and another one here about 25 miles wide.
Thunderstorms can create a very dangerous threat to pilots.
Since there was severe weather in the area, we always worry about microbursts.
Microbursts occur when columns of air shoot down to Earth. As a plane passes through, Winds batter it from all directions, making it difficult to control.
In a microburst condition, you can get very shifting winds and also vertical winds that try to push the airplane into the ground. So you can get loss of airspeed, a very rapid rise in airspeed, and then also actually push the airplane toward the ground. And it requires very aggressive flying on the part of the flight crew.
This unusual weather condition had killed before. In 1985, a microburst brought down a Delta Airlines flight in Dallas, killing 137 people. At the time of the Detroit accident, there was no device at airports to accurately detect microbursts. Instead, pilots relied on reports from other crews. Jack Drake discovers that 27 minutes before liftoff, Captain Mouse and First Officer Dodds received such a warning.
Ground, this is 722. You just had a microburst out here. The dust just exploded down there.
Investigators suspect that a microburst may have slammed Flight 255 to the ground as it tried to lift off.
It was right after departure when the accident occurred. If they had struck a very strong microburst, that would be a candidate for one of the possible causes.
Satellite images taken at the time of the crash and weather data from the airport's sensors show that there were storms near the airport at the time of the accident. But there's no evidence of a microburst.
Wind and rain, but nothing that could be a microburst.
Around the time of the crash, the airport's sensors did record a dangerous gust of wind on the runway, powerful enough to set off alarms in the tower. Upon further investigation, Drake discovers that Flight 255 was still at the gate at the time of that alarm. So the winds couldn't have brought the plane down.
Sign beacons.
But they did have a huge effect on Captain Mouse's flight plan. The crew's pre-flight dispatch package stated that they would take off from runway 21 left. But with the sudden change of wind direction, ground control sends Flight 255 to runway 3C, the shortest of 3 available runways.
Northwest 255, now exit at Charlie, runway 3 center.
Okay, out to Charlie for 3 center, Northwest 255. Charlie for 3 center right.
Okay.
Controllers try to have planes take off into the wind. The additional wind flowing over a plane's wings gives it more lift and helps it get off the ground. Taking off into the wind is safer, but taking off on the shorter runway now means First Officer Dodds must recalculate the plane's takeoff weight.
There's a runway change. You have to determine if the weight of the aircraft will permit it to accelerate and climb out safely. And this varies depending on the length of the runway, temperature, altitude of the airport.
Perhaps First Officer Dodds made a mistake in his calculation.
44.4. How can we be that light for a full airplane?
If he did, it could explain why the MD-80 wasn't able to make it off the ground. Runway 3C simply wasn't long enough. Using calculations based on average weight of luggage and passengers on board, Drake's team confirmed Dodd's estimate. The plane weighed 144,047 pounds, well below the allowable limit for runway 3C. It should have been able to get off the ground. Drake's investigation has hit another dead end. He and his team are running out of possibilities. Until technicians can decode the damaged flight data recorder, the team must rely on the physical evidence that's been found at the crash site. But when investigators study the cockpit's center console, they're forced to consider an almost unimaginable cause.
Is this the way it was found?
To get the plane off the ground, the flaps on the wings should have been extended to the 11-degree position. But the way the flap handle is damaged suggests the plane's flaps were retracted when it crashed.
The pin had left a mark. This happens because the aircraft comes to a very sudden stop and the handle jangles around, and it's a metal-to-metal contact that's exaggerated by the impact.
Well, stay on.
That indicator was that the flaps were zero or fully retracted and the slats were retracted as well.
Flaps and slats are extensions that slide out of the back and front of the wing. They make the wing bigger, which increases the amount of lift they can provide. They must be extended for takeoff.
If the slats are retracted, and for the most part, with today's modern jets, the airplane is not capable of flight. It's not capable of flight.
If the crew tried to take off with the flaps retracted, it would be an astonishing blunder.
B1, rotate.
But a pilot who was lined up directly behind Flight 255 on the runway is certain the plane's flaps were extended.
And you're sure the flaps were extended?
Pilots in other aircraft that were close to the point where the takeoff had begun were telling us that they thought the flaps and slats were deployed to a normal position.
Investigators can't be sure whether the flaps were extended or not. The clues they need lie somewhere in the sea of debris recovered from the crash site. Eventually, investigators find the evidence they need inside a section of the plane's left wing.
Each component of the slat system has its own drive system, and one of those was interrupted by the light pole that passed through the wing. 18 feet of the left wing was severed.
The cable controlling the slats was sliced in two when the wing hit the light pole. Based on where the cable was cut, investigators can tell whether the slats and flaps were extended or retracted.
It severed two cables, and if you lined up those two severed ends, it corresponded with the slats being in the full retracted position.
It looks increasingly likely that the crew never extended their flaps. Only the damaged flight data recorder can verify this. Fortunately, technicians have finally been able to rescue all its data. A digital history of Flight 255's performance until the moment of impact.
I knew that if we had a good recorder, we were going to get data back. The flight data recorders in combination give you that time history that goes together with the physical evidence or physical damage.
As expected, the FDR confirms what the evidence has been showing investigators.
Flight data recorders told us that the flaps and slats had not been extended.
It's a major breakthrough. Drake now knows what brought down Flight 255. But the flight data recorder doesn't answer a more troubling question.
So, why weren't the flaps deployed?
For some reason, a seasoned crew forgot one of the most basic steps involved in getting an airplane off the ground.
Switch the colors.
2 months after the crash, Northwest Airlines Flight 255's sole survivor, Cecilia Sheehan, is released from hospital.
We can't be sure why the little girl survived. She's a very little girl buckled into a big seat, and she was more protected than adults that might have been sitting around her. But she was very lucky.
Jack Drake needs to know what contributed to the death of her family and all the other victims. He finds an important clue on the cockpit voice recorder. It shows that the last-minute runway change caused confusion in the cockpit.
Once the aircraft began to taxi,
blacker than hell out there.
Northwest 255, no exit at Charlie Runway 3 Center.
other activities were introduced that had the potential to cause distractions.
Did he say 3 Center?
3 Center, yeah, that's why I was thinking we had to go that way.
I was thinking 2-1.
Well, they made a wrong turn, which might have been confusing because they had to go a different route.
Where's Charlie at?
Right at the end of this ramp.
I think Charlie was...
No, it is Charlie.
You sure?
I think so.
The crew got lost on the way to runway 3C.
Ground, Northwest 255. I guess we went by Charlie. We're going to 3 Center right.
Northwest 255, affirmative. Make a left turn at Foxtrot.
They finally got to the runway 45 minutes late.
Ladies and gentlemen, we're currently number 1 for departure. Should be rolling in a couple of minutes. Flight attendants, be seated. Thank you.
But Jack Drake finds something missing on the CVR. It seems the crew overlooked a very important step.
We're okay for the center runway, aren't we?
Before they got lost, the crew of Flight 255 performed a number of checklists. But possibly due to the confusion of the runway change, they seem to have completely neglected the taxi checklist.
They apparently didn't consider the checklist, and key in the checklist is the configuration of the aircraft for departure, and the flight data recorder showed that was never done.
There are hundreds of small steps for a crew to take to get a passenger jet off the ground. Most of them are covered by checklists.
The checklist is a means by which you ensure that important items are positioned or done properly.
Transponder.
Instead of doing it by memory and having the possibility of a lapse of memory.
Brakes.
Flight crews use a very rigorous and regimented procedure of following the checklist.
Pressure control.
Verify that each switch, each dial, each lever is in the proper position before taking the runway for departure.
The first item on the taxi checklist is flaps.
One of the things that would have been included in their checklist was to configure the slats and flaps for low-speed flight.
But because they didn't run the checklist, the crew never set their flaps to the takeoff position.
I think Charlie was...
No, it is Charlie.
You sure?
I think so.
They hadn't done this checklist at the time they normally would, and as the activities piled up that were potential distractions, they were further and further away from the point at which they would normally perform that function. Their mindset was probably that they had completed it.
The pilots got an indication that their plane wasn't properly configured. During takeoff, they couldn't activate the auto throttle because their computer wasn't in takeoff mode. Another step covered by the taxi checklist.
Won't stay on. TCI's on set.
This should have alerted them that they didn't perform the checklist.
If it had occurred to them at that point that we might have missed something else on the checklist, that could have led to a rejected takeoff.
They're on now. 100 knots.
Okay.
Apparently that didn't happen, and so the takeoff was continued.
With disastrous results. An alarm should have sounded when the pilots tried to take off with their flaps retracted. but for some reason investigators can't hear it on the cockpit voice recorder.
When it activates, it alerts the crew that the aircraft is not in a configuration that's safe for takeoff.
Maybe it went off, or we just can't hear it.
The investigation team is determined to find out why the takeoff warning didn't sound. Technicians analyze the cockpit voice recorder for more clues, and they find something unusual.
They picked up some enunciations on the CVR that were not correct.
Stall. Stall.
This warning is alerting the crew that the plane is about to stall. But it should be coming from 2 speakers in the cockpit.
Stall.
Technicians notice it's only coming from 1.
Stall. Stall.
As the airplane lifted off, there was a stall warning, and it has a typical characteristic of a sound like stall all, because there are 2 enunciations, and the purpose of that is to provide redundancy. But that redundancy wasn't there. We had a single stall. I went to an MD-80 sitting on the ramp at Detroit, and a captain took us through the process of checking out to demonstrate those different sounds.
Let's start with the config warning.
The takeoff configuration warning is what would have alerted them about the flaps and slats.
Flaps. Slats. Flaps.
Can we get the stall warning to sound?
Stall all. Stall all.
He activated the stall warning system by a test switch, and it said stall all.
The voice on the left channel is slightly different from the voice on the right, as it should be. But that's not what Clark heard on Flight 255's voice recorder.
Can you make it sound like this?
Stall. Stall.
To get a singular stall, he had to pull power to one side or the other. And one way he demonstrated that is he pulled the P40 circuit breaker.
A circuit breaker is the electrical switch that protects the circuit from damage caused by overload. The P40 circuit breaker is an important one in this investigation. It handled both the failed takeoff warning and the stall warning systems.
What struck me was, he said, I hear people doing it. I, of course, don't do it myself, but let me show you how. And he reached around behind him, around behind the seat and down low and pulled the P40 circuit breaker without looking. And then when he ran the stall warning system, we got the singular stall.
Stall. Stall.
It's a major clue. Clark could only reproduce the strange-sounding stall warning by pulling the same circuit breaker that's connected to the takeoff warning. This tells investigators that the breaker was tripped when Flight 255 tried to take off. Then John Clark notices something else about the P40 circuit breaker.
You could see smudge marks around the decals on each side of the circuit breaker. It looked like finger marks where oil had built up and dirt and grime over the years. So it told me that that circuit breaker was being used routinely by a lot of pilots.
Can you tell me why that is so worn?
It turned out that the takeoff configuration warning could be a nuisance to pilots.
If you're doing a single engine taxi, you have to push the throttle up further to get a power to taxi, and you would set off the takeoff warning system. And so they would pull the circuit breaker to silence it. It's irritating. It's a warning. It's meant to alert you. And if it's going off routinely all the time, it gets on their nerves. And so apparently pilots were routinely silencing those takeoff warnings.
Investigators suspect that the crew of Flight 255 tripped the breaker to avoid the irritating takeoff warning. And then, with the added delay from the runway change and the impending storm, they proceeded to take off without doing the taxi checklist. That might explain why the alarm didn't sound when they tried to take off with their flaps retracted.
We don't know if the pilot did pull that circuit breaker on that particular flight. There was certainly one error and the potential for two. I think that the extensive use of the circuit breaker because of the smudge marks around the circuit breaker and the pilot's statements, I think it's highly likely that he did.
It appears the downing of Flight 255 was caused by pilot error. Now investigators can accurately piece together what happened that night in Detroit. But it would take another shocking accident for the airline industry to learn its lesson. Jack Drake's team has discovered what caused the crash of Flight 255, but cannot prevent it from happening again. 1 year later in Dallas, Delta Flight 1141 tried to take off without their flaps extended. The investigators who had been working on the Northwest crash are stunned.
I was very frustrated to learn that another airline had done the same thing in a different aircraft type about a year later.
Hey, before
The Delta crash would uncover potentially deadly flaws
Before start checklist, battery.
in the checklists commercial pilots are trained to follow. The Delta and Northwest crashes killed 170 people and had eerily similar causes. In both disasters, the workload in the cockpit increased.
Jesus, look at this.
Northwest 255 now exited Charlie Runway 37.
If we get out of here pretty quick, we won't have a delay. Auto land.
And in both, the pilots failed to perform vital elements of their checklists.
It is very unusual for a crew to not perform a checklist. They have done it hundreds upon hundreds of times.
Brakes, windshield heat is on, cabin pressure controller is checked.
The normal procedures were a little bit out of the norm, and as a result, it got overlooked.
To prevent this from happening again, aviation officials turned to a government agency that knows the importance of clear procedures.
4, 3, 2, 1.
NASA.
So they're in there, ready to go. All right.
Jack Drake and his team wanted the US Space Agency to help create checklists that decrease the odds of items being skipped. Asaf Degani was a research scientist working with NASA. After the accident, he took on the project of improving a flight crew's pre-takeoff procedure.
We looked for any research that was done on checklists or procedures in general, and in fact, we couldn't find anything.
So Degani had to start from scratch. But there are dozens of different checklists to examine. Most of the ones on Flight 255 were printed on a single card. They listed the tasks the crew had to carry out, but didn't give them a way to keep track of what was and what wasn't done. At the time of the Northwest crash, there were several types of mechanical checklists in use. The US Air Force used a scrolling checklist. Once a checklist item is completed, the pilot scrolls to the next one. American Airlines used a system that allowed pilots to cover up completed items with a plastic slide, so only the non-completed items would be displayed. Asaf Degani set out to see firsthand how pilots were using checklists. He wanted to make it less likely for them to make mistakes. He sat in cockpits and observed 42 different crews in action. Degani concluded that many checklists were badly designed.
There's a certain flow by which you go about checking things, and the idea is to prevent a case where you're doing one thing here, one thing there. Checklist should have a certain flow, which is a logical flow, and not one which is kind of random. Go, and they're ready, and they're going through there.
Degani also found a much more serious problem with checklists. If pilots are interrupted, they sometimes forget where they left off.
Transponder. Checked and on.
And there's many cases where people would do A, B, C, D, E, and air traffic call would come, they'd have to respond to it, and that's an interrupt.
Northwest 255, now exited Charlie Runway 3 Center.
They will go back to the checklist and skip a certain item and continue on the list, assuming that the whole list was done. People were very concerned about that.
To ensure no steps are missed, airlines train their pilots to return to the top of a checklist following the interruption and start over. Again, Asaf Degani sees a problem.
And we found that if checklists are very, very long and meticulous, that's overburdening the crew, and they sometimes would not want to start again from the beginning.
To address the problem, Degani suggests changes across the airline industry.
One of our recommendations from the study is to try to take long checklists and chunk them to small pieces so that if an interruption happens, then doing another 4 or 5 items, it's not a big effort as opposed to doing 20.
Degani even made recommendations about the typeface that airlines use, so they can be more easily read by pilots. Perhaps the biggest advance to checklists is the move from paper to computers.
Since at the time computer technology was coming into the cockpit, it made a lot of sense to think about the electronic checklist.
Today, Degani and his team are studying smart checklists that keep track of checked items. They provide pilots with a visual indication of where they are on the list, and in some cases verify that the task has been correctly carried out.
Electronic checklist shows you which item was completed and which item was not.
Computerized checklists are now slowly making their way into the cockpits of commercial airplanes. They make it far less likely that an accident like Northwest 255 could happen again. The FAA also ordered a modification to the alarm system of all commercial jetliners to prevent nuisance alarms. The takeoff warning was redesigned, so it could not sound unless the plane was actually taking off. Jack Drake went on to investigate hundreds of accidents over a 26-year career with the NTSB. The crash of Flight 255 taught him a valuable lesson.
This one is a worldwide example of the importance of following checklists and configuration being completed correctly on every takeoff. And so it became something that was a part of the training curriculum in virtually every airline around the world.
The case of Northwest 255 is no different. It's a series of events, runway change, task saturation, an overlooked checklist, a failed takeoff warning system. Put all of those together, those links in a chain, and you end up with the accident. If you were to break any one of those links, the accident wouldn't have happened.
Flight 255 will also be remembered for its lone survivor, Cecilia Sheehan. She's never spoken publicly about the death of her family. But she's stayed in touch with the people who rescued her that day.
She's full of life, and the conversations we have, it's more about, her sports and her husband and her vacations. She just said maybe one day she'll come out and tell the world what Cecilia is doing.
It's the first public demonstration of the world's most sophisticated passenger jet.
Okay, you're at 100 feet there.
100.
The Airbus A320 is being introduced to the world.
Mesdames et messieurs, votre attention s'il vous plaît. L'Airbus A320 arrive.
That introduction turns into a fatal calamity.
30. Can't be. 30.
It could not possibly have come at a worse time for Airbus. The crash was a major embarrassment.
There's enormous pressure on investigators. If Airbus is to survive, they must find the answer to one crucial question.
Was it the pilot or was it the plane?
It's 2:30 in the afternoon on June the 26th, 1988. An unusual charter flight prepares to depart Basel-Mulhouse Airport in France, near the Swiss border.
Anti-ice.
Captain Michel Asseline is one of Air France's most distinguished pilots.
On.
Though only 44, he's the head of pilot training for the company's newest plane, the Airbus A320. It's only the third of its kind to roll off the assembly line. Captain Asseline flew this very aircraft from the factory in Toulouse just 2 days earlier.
I was in charge of the launching of the 320 in Air France. The company used me to promote the aircraft. The speeches to make, I was constantly on the television, on newspaper.
Air Charter 296 would like to roll, please.
Asseline's first officer, Pierre Mazière, is also a senior Air France pilot.
Air Charter 296.
He's invited 2 off-duty flight attendants to come along for the ride on this special flight. The aircraft is booked to perform a low-altitude flyover at a local air show. There are 130 people on board this A320, which is unusual for an air show demonstration flight. They have no luggage. For some, it's their first time on an airplane. There are even children, like 7-year-old Mariama Bari, unaccompanied by their parents. After the flyover, they will be taken on a sightseeing tour around Mont Blanc, the highest peak in Western Europe. Most got their tickets as promotional gifts from a local bank and newspaper. Jean-Marie Schreiber is a young reporter covering the launch of the new plane.
As a journalist, I was thrilled to be on the flight, to have a chance to see how people reacted inside the plane.
Another journalist aboard, Jean-Claude Boche, has been busy recording the event.
As I got on the plane, I thought, great, this is going to be an unforgettable experience. And it really was unforgettable.
The A320 is the first civil aircraft to use fly-by-wire, a cutting-edge technology that computerizes flight controls. The system had previously mainly been used by the military.
On the fly-by-wire system, the pilot essentially flies the computer, and the computer flies the aircraft.
Fly-by-wire alters the relationship between pilot and plane. It gives computers the ability to override human inputs to prevent pilot error. The A320's flight computer won't let its human operators do anything it determines to be dangerous. Airbus has become the first civil aircraft maker to embrace this technology. It hopes this will give it an edge over its longtime American rival, Boeing. In its first public presentation, Airbus has a lot on the line.
Okay, tell me what you want in terms of speed and altitude.
Okay, then take off, right turn. We go nice and easy to find out things.
We tried to demonstrate the capability of this aircraft. To say we wanted to show off, not exactly. We wanted to make a good job, and we were sure to make a good job.
Once we identify the airfield, we extend flaps to 3. We'll do the flyover at 100, landing gear out, and you just leave it up to me. I'll give it Alpha Max. Done it 20 times.
Okay.
Captain Asseline is planning a breathtaking maneuver. A low-altitude, nose-high flyby at Alpha Max. This is the slowest a plane can fly without stalling.
Ladies and gentlemen, hello, and welcome aboard this Airbus A320, which was put into service just 2 days ago. We will soon be taking off for a short sightseeing flight, which will start from the Alpsheim Flying Club, and then we'll be flying around Mont Blanc. I wish you a very pleasant flight. That's done.
ACF 296Q, clear for takeoff. Runway 16.
We're rolling. Take off. Go. Over.
It's already requesting climb. You see that?
Yes, that happens. I know the bug.
V1. Rotate. Gear up, flaps 1. After take-up checklist completed.
It's only a 5-minute flight to Habsheim Airfield, where the airshow is being held. For this sleepy Alsatian town, the airshow is the highlight of the summer.
The airshow drew more than 5,000 people. There was significant interest from the public.
The airfield is so small, its coordinates aren't stored in the plane's navigation database, so the pilots must find it by sight.
You're at 8 nautical miles. You'll soon see it. There's the highway.
We leave the highway to the left, don't we? No, to the right of the highway.
It's slightly to the right of the highway.
There's the airfield. You've got it, have you?
The pilots have spotted the airfield late. They will have to hurry to descend to the planned altitude for the flyover at the airshow. A crowd is forming at the runway.
Air Charter 296, good afternoon.
Habsheim, hello. We are coming into view of the airfield for the flyover.
Yes, I can see you. You're cleared. The sky's clear.
Gear down.
Okay, we're going in for low altitude, low speed flyover. 296.
Roger.
Flaps 2.
Quebec November Hotel, Absane, Fox Echo 984.
Okay. 984. Put in 984. Flaps 3.
Flaps 3.
That's the airfield. You confirm?
Affirmative.
Flight 296 makes a gentle turn to line up with the runway. The pilots must now lose more altitude and speed to get into position for the flyover.
200. 200.
Mesdames et messieurs, votre attention s'il vous plaît. L'Airbus A320 arrive.
Okay, you're at 100 feet there.
100.
Watch it.
100.
Watch it.
The aircraft is now at the planned altitude. For Asseline, this will be the most delicate part of the maneuver. He must keep the plane in a stable position with the nose up, but not too high.
I looked at the ground and said, look, he's not high enough, because you could see the grass right out your window.
Okay. I'm okay there. Disconnect auto throttle.
He disables one of the plane's safety features so that the computer won't speed up the slow-moving plane. Only now, Captain Asseline sees a danger that threatens the lives of everyone on board. The A320's low-speed flyover at the Habsheim airfield is suddenly not going according to plan. There's a forest in the path of Captain Asseline's plane.
30.
Take off, go around power.
He selects the highest thrust setting and pulls back on the controls, expecting the aircraft to pull up. But the plane keeps dropping.
Can't be.
I started to see through the window tree branches. I was astonished. You can imagine being on a trail in a large vehicle, a bumpy trail, driving at 80 or 100 kilometers an hour, and you're shaking from all sides. It was like that. I was saying to myself, the plane has to stay in one piece, because if the plane stays whole, we'll be okay. If it breaks up, we're done for.
S'il casse, c'est fichu.
Still full of fuel, the right wing of the jet is sheared off. The fuel ignites immediately on impact.
and we stopped very quickly. And on the ground, I broke my seat, just because I was holding very firmly. I broke my seat, and I could see lot of flames all over. But about 20 meter high flames around the cockpit, smoke coming from everywhere.
The first officer is badly injured.
And he has a lot of blood, and even with the full harness, he hit something in front of him.
What the hell have you done?
I don't know. I don't understand.
There was a moment of silence when the plane finally stopped.
Incredibly, the fuselage is still in one piece. Everyone has survived the impact, but they're not out of danger yet.
So I lean to the right, and I see red flames. The windows were red. And I think, we held together, but we're going to burn to death.
Then we heard somebody say, get out, there's a fire.
Sortez, sortez, il y a le feu.
Evacuate the aircraft. Hurry, I'll deal with him.
Only 2 exits can be used for evacuation. The rest are engulfed in flames. But thick branches block one of the doors, making evacuation difficult. In the chaos of the cabin, some passengers struggle with their seatbelts. Marie-Françoise Froche is one of the last passengers to leave her seat. She comes across Mariama Barry, who's trapped in her seat.
Mariama Barry. She was 7, 8. After the accident, people pushing toward the exit pushed on the backs of the seats, the backs that folded over her, and then she was trapped by her seatbelt. No one saw her. She was forgotten.
But it's too late. Both are overcome by smoke before they can get off the plane. In the cockpit, Captain Asselineau struggles to get his injured first officer out of the burning aircraft.
I took him from his seat and belt him, carry it, I don't know how, and I put it in a slide. When the passenger, all of them, the last one, was out of the plane, I saw my crew. They told me, Captain, they are all out. I couldn't believe it.
But the crew is wrong. Not all the passengers have made it out. Marie-Françoise Froche, Mariama Barry, and another young boy are dead. In addition to the tragic loss of life, the accident is a PR disaster for Airbus.
The crash could not possibly have come at a worse time for Airbus. They were trying out this new concept, which they had touted very widely as a new level of safety for civil flight. And here's a pilot going and crashing one. For those who actually saw the accident, and it was broadcast on the news media throughout the world the same evening that it happened, there was amazement. The crash was a major embarrassment.
Investigators from France's Accident Investigation Bureau are on the scene of the crash within hours. They need to know why this demonstration flight ended in disaster. They recover the plane's data and voice recorders. Claude Béchet will head the investigation.
Was it the pilot or was it the plane? We need to know.
Like the pilots of Flight 296, he also works for Air France as an airline captain.
Let's get to work.
Which is unusual for a state investigator.
At that time, I was still an airline pilot. And I was in New York when the accident happened, and they sent me a telegram to ask me to come back to Paris as soon as possible.
Apart from the flight recorders, investigators have a remarkable piece of evidence to consider. A high-quality video of the accident has been recorded by a French cameraman.
It was the first time we had a video of an accident, you know. Normally, an accident happens in the middle of nowhere, where nobody is there with a camera to film it.
The tape clearly shows the plane flying right at the trees at the end of the runway. It doesn't seem to be climbing at all. The cockpit voice recorder offers a confounding clue.
Take off, go around power.
30. 30.
Get me!
It's clear the crew had no idea there was an obstacle at the end of the runway. Investigators are puzzled. How could a forest take a pilot by surprise? Bechet brings Captain Asseline in for questioning about the flyover at Habsheim. They need to know what his plan was.
My intention was to carry out a flyover at slow speed.
As a qualified A320 pilot, Claude Bechet is familiar with the plane's capabilities.
Over the airstrip and we go to Alpha Max.
Very good.
He sees nothing wrong with Captain Asseline's plan.
It was not bad. Making a slow pass was well planned. And he seemed to me to be very open and very ready to help to work with the investigation commission.
Investigators turn their attention to how Air France prepared the flight crew for the airshow. They discover a memo setting out the rules for all airshow flights. What draws the attention of investigators is the minimum altitude Air France had selected for airshow flyovers: 100 feet. It was in violation of national regulations.
He should have been at 500 feet, as a matter of fact. But there had at that time a tendency for pilots who were making air shows like that to go a little bit lower and sometimes much lower.
Chief Investigator Claude Bechet now wonders if there were any other mistakes in the planning of the flight. He soon learns that Air France's flight division didn't start drawing up a flight plan for the demonstration until less than 48 hours before the airshow. An Air France employee had prepared maps of the airfield for the crew of Flight 296. Investigators find a serious problem. The forest around Habsheim airfield did not show up on the photocopies. The employee who had put together the flight package didn't have an opportunity to discuss it with the crew.
You were using an evacuation shaft?
While questioning Asseline, Bechet discovers that the pilots were also given little time to prepare.
Happened then. Here's the flight package. Thanks.
That's highly unusual for an airshow.
My co-pilot told me, okay, we make a flight around Mont Blanc, and then we have to make 2 low pass of a small airport, Habsheim. Told me there is nothing special. So for me, it was a normal flight, a normal day.
That preparation had not been complete, and there had been no briefing of the crew by the staff.
Investigators then make an intriguing discovery at the crash site. They measure the height of the trees hit by Flight 296. They discover the average height of the forest to be only 40 feet. This poses an urgent question. How could an Airbus that was supposed to be flying at 100 feet hit trees less than half that height? It is clear to investigators that Flight 296 fatally deviated from its original flight plan, losing altitude before plunging into a forest. But only the black box data can help them understand how and why this had happened. Information from the A320's flight data recorder is recovered within hours of the crash. The device records information about 200 aircraft functions. It paints a detailed picture of how Flight 296 was operating in the final minutes of its journey.
Can be!
We could reconstruct the entire accident. We could live with the crew as the accident was happening.
Investigators make two striking observations from the data. The first is that Flight 296 suffered no mechanical breakdowns. The second is that the A320 followed a very different flight path than the one Captain Asselinean had planned. Instead of maintaining a stable airspeed and altitude, Flight 296 had slowed down and lost altitude as it performed the flyover. As the A320 crossed the Habsheim airfield, its speed dropped to only 112 knots. That's about as slow as an A320 can fly. The plane's deceleration was so dramatic, it was even visible on the video. Michel Asselinean was one of Air France's top pilots. Claude Béchet is hard-pressed to understand how he could have mishandled such a high-profile flight. Pressed further, Asselinean explains how the trouble started.
You were using a navigation chart?
Yes, we had some difficulty locating the airfield.
Leave the highway to the left, don't we? No, to the right of the highway.
It's slightly to the right of the highway.
There's the airfield. You've got it, have you?
They spotted the airfield too late. So when they did, they reduced the power and they descended.
So they rushed their descent in order to get into position for the flyover.
And they were still slowing down when they reached the airfield.
That's the airfield. You confirm?
Affirmative.
But then another problem emerged. The spectators were lined up on a different runway from the one the crew was heading for. The crew of Air France Flight 296 is ill-prepared for their demonstration flight. In planning for the airshow, Air France only provided the crew with information for Runway 2, Habsheim's only paved airstrip. But Captain Asselinean sees the crowds aligned on a much shorter, adjacent grass field.
I was expecting a normal runway. At the latest moment, I saw that it was a grass runway.
Captain Asselinean lined up with the grass strip.
I had no idea that at the end of the runway was a forest. For me, it was bushes only or something.
Okay, you're at 100 feet there. Watch it. Watch it.
Because they had to rush their descent, by the time Flight 296 got to the airfield, it was flying too fast. To lose speed, Captain Asselinean kept the thrust on its lowest power setting, well below the setting pilots normally use for Alpha Max flight. But another serious problem was developing. The aircraft had dropped below 100 feet and was continuing to fall. And the crew didn't seem to notice.
I'm okay there. Disconnect auto throttle.
In a matter of seconds, the altitude had fallen to only 30 feet.
What was extremely clear is that airplane was flying at approximately 30 feet above the ground. Regardless of any other data, this data was extremely important.
Take off, go around power.
No airplane of that size or of any other size should make a flight path that low.
The data is clear. You were at 30 feet, not 100.
I believed I was at 100 feet.
Claude Béchet is still uncertain how the A320 ended up so dangerously close to the ground. Captain Asselineau insists his instruments failed him.
Flaps 2.
Quebec November Hotel at St. Fox Echo 984.
Okay. 984.
Captain Asselineau was relying on his barometric altimeter. It uses air pressure to measure the plane's distance from the ground. It had to be set to local atmospheric pressure to be accurate.
Quebec November Hotel at St. Fox Echo 984.
Okay. 984. Put in 9.
The cockpit recorder proves that the tower provided the pressure reading and the crew set their instrument. But Asselineau insists the altimeter was giving him a false reading.
I tell you, the altimeter said the plane was at 100 feet.
Michel Asselineau stated that the barometric altimeter was, in fact, to be precise, 67 feet out. And that is something that he claims led him to be flying at 30 feet instead of at 100 feet.
Investigators are skeptical. Asselineau had more than one instrument to give him altitude information. The A320 has a second altimeter that uses radio waves to calculate the plane's distance from the ground. That altimeter displays the altitude on a digital display. But Captain Asselineau claims it was difficult to read.
We could not use the radio altimeter because this radio altimeter is digital and nobody can fly by reading numbers. I tried that later on a simulator. I never succeed to do it.
But the radio altimeter has another way of alerting pilots.
I'm okay there.
50.
A digital voice call-out.
Disconnect auto throttle.
But Asselineau claims he and his first officer, Pierre Mazière, could not hear it.
Some people say, but you could have heard the radio altimeter saying 30, 30, 50, 40, 30. No, because at that time this aircraft was very, very noisy. And we have the headset. And we have demonstrated at that time that the radio altimeter warnings or the radio altimeter call-outs, they were not going through the headset.
50.
Despite Asselineau's defense, investigators are certain that the crew of Flight 296 mishandled a risky maneuver. Bechet has more questions for Captain Asselineau.
What did you do when you saw the trees?
I did what any pilot would do. I tried to climb over them.
Investigators learn that in the final moments before the crash,
30.
Pick up, go run power.
Captain Asselineau applied full throttle.
When I was waiting for the engine to spool up, that I realized in front of me there were trees. And I was waiting.
But he claims the engines did not respond. And when they finally kicked in, it was too late.
I tell you, the engines did not come on when I gave it full throttle.
Captain Asselineau's testimony raises a troubling prospect. If there was a prolonged delay in engine response, it could indicate a critical problem with the A320's turbojets. Captain Asselineau is convinced the engines didn't respond quickly enough in the final seconds of the flight. He makes it his mission to prove it. He uncovers an Airbus document warning of a defect on the A320. It says the plane's engine speed could stagnate at low altitude, a condition caused by poor airflow. When this occurs, the engine cannot accelerate. But investigators can find no evidence of such a failure in any of the data from the plane.
30.
Pick up, go run power.
In the 5 seconds after Captain Asselineau applied full power on the thrust levers, the A320's twin engines had begun to spool up. They reached 84% thrust, close to full power, just before the plane hit the trees.
When you put from idle to full power, you have the impression that nothing happens for a few seconds, and then the power comes. That was normal, exactly as predicted by the certification.
Investigators are increasingly certain the engines on Flight 296 didn't fail. They find a novel way to verify the data. Video of the crash picked up the distinctive sound of the A320's engines accelerating. By studying that sound, engineers can determine how much power the engines were generating in the final seconds before the crash.
We were able to compare the RPM of the engines from that film and from the flight data recorder. There was nothing wrong with the engines, any of the two engines.
Why?
Chief Investigator Claude Béchet has a new headache. Captain Assouline is convinced there is a conspiracy against him. He cuts off all cooperation with the investigation.
Very well.
Investigation committee, I tried to cooperate with them, but I began to be suspicious. And the press, each week, the aircraft is good, the aircraft has nothing, pilot error, pilot error, pilot error. All that was a big, big, big cover-up, my opinion.
Captain Assouline begins a campaign to challenge the French investigation. He appears on British television to make a dramatic assertion.
When I pull the stick to up position, the flight controls, the elevator control go to down position. So on any aircraft, if you ask up, following the order of the pilots, the elevator control goes to up. And not that on that one, it went to down. Why? That would be the good question.
His accusations go to the heart of doubts about the aircraft. That Airbus fly-by-wire system had given the A320's computers too much control. Assouline's claim that the plane didn't follow his instructions is supported by data from the plane's flight recorder. The black box recorded every movement of the pilot's side stick controller. It does show that seconds before the crash, Captain Assouline pulled it back to get the plane's nose up. Investigators compare it with what the plane did in response. They make a perplexing discovery.
He's telling the truth. The elevator moved down.
In the final seconds before the accident, the pilots had desperately tried to pull up. The side stick controls the plane's elevator. Pulling back on it should raise the elevator and pitch the plane upwards.
30.
But that's not what happened on this flight.
One of the strange things about the crash flight, which became apparent when the digital flight recorder was analysed, was that during the last few seconds prior to contact with the trees, the pilot was dragging back on the stick as hard as he could, but the flight surfaces were moving into a position to put the nose down.
Captain Assouline believes the plane's descent triggered an automatic response by the flight computers. Assouline inadvertently brought his plane to within 30 feet of the ground with his landing gear down and his flaps extended. Investigators now wonder if the plane's computer determined that Assouline was landing and initiated the necessary steps to accomplish that.
As the plane leveled up with the airfield, it overflew a little copse of trees which took the radar altitude momentarily below 30 feet. That would have been sufficient to trigger the flight control system to enter landing mode.
It's possible that in spite of what Captain Assouline was commanding the plane to do, the computer brought the plane's nose down for landing. Investigators must try to determine whether the A320 overrode its pilot at a critical moment. They analyze the data from the flight recorder.
Stop it there.
But to their disappointment...
So was the plane in landing mode or not?
The flight data recorder can't confirm if the plane went into landing mode. The A320 systems are so advanced that the recorder can't track all of the plane's functions. Investigator Claude Béchet comes up with another way to find out. He replicates Assouline's approach to the Habsheim airfield to see how the A320 responds.
Okay, let's start the descent. Power to flight idle. Now put it into Alpha Max. That's it. Gently.
I replayed the accident, but on the longest runway in Toulouse.
Altitude, 40 feet, 35 feet.
We replayed the accident exactly what it was.
Béchet's plan is to descend to 30 feet, as Asseline's A320 did.
Now pull up slightly to level off. Hold it there.
Béchet wants to see if the flight computer puts the plane in landing mode.
Okay, now full thrust. Did you feel that? Alpha protection.
The test flight has triggered a nose-down response from the plane's computers, like the crash of Flight 296. But the plane hadn't gone into landing mode. Instead, the flyover had activated one of the A320's main safety features: stall protection. Due to a lack of airflow over the wings, flying slowly in a nose-high position can cause a plane to lose lift. The A320's computer has been programmed to bring the plane's nose down when it gets close to stalling.
This means that in theory, as long as the flight control system is in operation, the pilot cannot stall the plane.
Béchet concludes the flight computers did override Captain Asseline's command. But he believes that by doing so, it had prevented the plane from stalling and crashing just short of the tree line.
That airplane didn't stall and, let's say, landed on the trees.
The investigation into the crash at Habsheim is coming to an end. Claude Béchet prepares to deliver his verdict.
The conclusion of my report was that the airplane was too low, too slow, and with not enough power.
As far as Claude Béchet is concerned, the report is the final word on the Habsheim tragedy. The case, however, is far from over. The French justice system is moving towards a judgment of Captain Asseline. He is charged with involuntary homicide in the deaths of 3 passengers and faces the prospect of a long prison sentence. But Captain Asseline believes he has found evidence that will exonerate him. He is convinced there was a conspiracy to tamper with the plane's black boxes, to conceal problems with the A320's fly-by-wire technology.
There has been a cover-up with some funny recorders. That's the first point. The second point, they have been changing the content of the recorders.
It all begins, according to Asseline, at the crash site. An employee of France's Civil Aviation Authority is photographed carrying the A320's flight recorders from the scene. Those same black boxes are presented as evidence at Asseline's trial. But inexplicably, they look different.
I had a chance to see the black boxes held by the court. But when I see the state they're in, they're old boxes, full of scratches, dusty, with chipped paint. I think, wait, these can't be the boxes from the crash. The plane was new. They're not the right ones.
Captain Asseline hires a Swiss criminology institute to compare the 2 photographs. Its conclusion, they're not the same flight recorders. Captain Michel Asseline claims the black box data from his flight has been tampered with. But investigator Claude Béchet rejects the accusations as outrageous.
They were trying to prove that the tapes had been tampered with, which we could not understand because Every recorder expert knew that it was physically impossible.
But there is one expert who believes the black boxes are suspicious. Ray Davis is a former head of flight recorder analysis at Britain's Air Accidents Investigation Branch. He has been hired by British television to review the French investigators' work.
It was a little bit of an eye-opener in a way, in that prior to reading the report, I had a totally different impression of the possible causes of this accident, whereas when I read the report, there were so many anomalies and questions raised by the report that my whole attitude towards the accident changed completely.
Davis discovers evidence that could vindicate Asseline. It raises questions about when the crew applied power to try to overfly the trees.
30.
Take off, go run power.
30.
While studying the black box data, Davis comes across a curious inconsistency. French investigators had synchronized the black boxes with a transcript of air traffic control communications. Davis examines the last conversation the pilots had with the tower before the crash.
984. Okay, 984. Put in 984.
It was recorded by both air traffic control and the plane's own black box.
Quebec November Hotel at same Fox Echo 984. Quebec November Hotel at same Fox Echo 984.
Ray Davis discovers a time discrepancy between the two recordings, amounting to a loss of several seconds. According to the black box data, the aircraft was 5 seconds from impact with the trees when Captain Asseline commanded full thrust from the engines. But according to Ray Davis's analysis, this actually took place 4 seconds earlier. This 4-second gap dramatically changes the calculus of the accident. It's the difference between a normal delay in engine response and a serious malfunction.
Asseline claims that on this particular occasion, the delay was more than he expected. And depending upon which side of the argument you come down at as to whether or not the 4-second delay in the digital flight data recording was real or not, then, you know, he's either an idiot or he's right.
The French justice system does not believe that Asseline is right. After multiple appeals, Michel Asseline is convicted of involuntary homicide and sentenced to 10 months in prison. Still, the controversy over the black boxes and the missing 4 seconds lingers on. It promises to forever cloud the results of Claude Béchet's investigation.
The public opinion thought probably, oh, well, there was so much at stake, you know. It was the future of all European aviation industry, which was at stake. So they managed to tamper the tapes so they could blame the pilot and not the airplane. But this is just impossible.
The investigation into the Habsheim accident made several recommendations. It calls for passengers to be banned on all demonstration flights. It also calls for better reconnaissance of airfields by flight crews. And they want airline procedures to be reviewed to ensure they conform with official regulations concerning altitude. Michel Asseline went on to a career as a teacher and inventor in the aviation industry. He continues to appeal his conviction and has devoted much of his life to clearing his name. The tragedy at Habsheim would have little impact on Airbus industry. The A320 would go on to become one of the most successful commercial aircraft in history, selling over 750 planes in its first 10 years. And fly-by-wire technology would be safely adopted by a new generation of passenger aircraft.
75, good night now.
Sundance 518, taxi across runway 24 left. Contact ground point 65 when off.
February the 1st, 1991. Los Angeles International Airport, LAX.
246 heading 270, contact Los Angeles departure. Thank you, US Air 1493. You're cleared to land 24 left.
Cleared to land, 24 left, 1493.
Traveling at 240 kilometers per hour, US Air Flight 1493 descends towards runway 24 left.
What the hell?
I pointed to the aircraft and yelled, US Air is crashing. The aircraft was fully engulfed in flames.
But the full scope of this tragedy is far greater than anyone can imagine.
Mayday, Mayday.
At one of the busiest airports in the world, a Boeing 737 has just exploded in flames upon landing.
I think the thought process in the tower was, it was 1991, it was one of the first nights of the first Gulf War. And I think the thing that was foremost in our mind was maybe it was a bomb that went off on the aircraft.
As firefighters bring the blaze under control, rescuers begin searching for survivors.
About 5 minutes after the incident occurred, we got a call from an emergency vehicle.
Amid the wreckage, they have made an alarming discovery. One that forces everyone involved to re-examine every detail of the last 15 minutes. US Air Flight 1493 cruises towards Los Angeles International Airport. LAX is a central hub for international travelers.
Just confirm the visual approach for US Air 1493 is 24 left.
That's correct, US Air 1493.
For the approach, Captain Colin Shaw is managing radio communications. First Officer David Kelly is at the controls. With 89 passengers on board, the flight isn't quite full.
Well, I'd been on a business trip to Columbus, Ohio. I went from the business meetings to Columbus Airport and got on a US Air flight that was nonstop to Los Angeles. I planned a lot of good things and good times for that weekend.
US Air 1493. Expedite your descent through 4000 as much as practical, if you would. There will be traffic pass above you on the south side.
As the Boeing 737 nears Los Angeles, the approach controller tells the pilots to make a quick descent. They will need to stay clear of a flight passing above them.
Okay, I'll expedite through 4. US Air 1493.
Landing at LAX can be a challenge for pilots. The airspace around the airport is often thick with traffic. On average, a plane arrives or departs every 50 seconds. Each of its 4 runways handles both takeoffs and landings. Taxiways intersect the runways at dozens of locations. The airport can be a maze of stops and starts for pilots following instructions issued by controllers.
737, turn right 010, intercept 4 right. You got the left side in sight? Yeah. We're out of 4.
US Air 1493. Thanks for your help. Contact Los Angeles Tower 133.9. Good night.
Good night.
Gear down?
All right. You gave 3 bells?
Yes, I did.
Perched 12 stories above the ground, tower controllers have a hawk's eye view of traffic coming and going from the airport.
It was a busy night. There was a lot of airplanes. We had numerous arrivals and departures during that time of the night, so it was a typical day.
Elliot Brann is the clearance delivery controller.
The primary duties of the clearance delivery controller is issuing the routes of flight and the flight plans to the pilots as they come out of the computer. A flight strip is printed out, so you get a piece of paper with the call sign, type aircraft, route of flight. I issue the clearance to the pilot, and then I pass the strips, the flight information, to the next controller.
Brann shares flight information with 4 other controllers. 2 ground controllers who handle planes moving between the gates and the runways, and 2 local controllers who are responsible for planes taking off and landing. Tonight, local controller Robin Washer is overseeing the 2 north runways at LAX, 24 left and 24 right. She uses the flight strips to keep track of flights departing and arriving.
US Air 23 taxiing to position and hold runway 24 left.
Position and hold 24 left. US Air 23.
246, you still holding short of 47?
46, affirmative.
All right, you're next. SkyWest 569, taxi up and hold short of runway 24 left.
Roger, hold short.
$28.75. Good night now.
US Air Flight 1493 is about 13 kilometers from LAX. The pilots configure their plane for landing.
Speed brakes. Still working for a living.
All right. Flaps are going 1.
Flaps.
Now the pilots radio the LAX tower for landing instructions.
US Air 1493, inside rolling.
Wings 5006, ground, tower.
Robin Washer is busy with other planes. She doesn't respond to their radio call.
SkyWest 569, taxi to position, hold runway 24 left. Traffic will cross downfield.
Okay, 24 left. Position and hold. SkyWest 569.
Wings west 5006, tower.
At 2166, connect approach 124.5.
30, green lights to 10.
Gear, flaps, landing clearance remains.
Just 6 kilometers from the airport, the US Air jet still doesn't have the okay to land.
Sundance 518, taxi across runway 24 left. Contact ground 0.65 when you're off the runway. Good night.
Captain Shaw contacts the tower for the 2nd time in less than a minute. He needs Washer's permission to land.
US Air 1493 for the left side. 24 left.
246, heading 270, contact Los Angeles departure. Good night.
But she's still focused on other planes.
Out of 1,000 feet.
Flight 1493 is now 1 minute from the runway. It's what pilots call short final.
Sometimes due to other priorities that take place, an aircraft might not get a landing clearance until short final.
Thank you, US Air 1493, you're cleared to land. 24 left.
Cleared to land, 24 left, 1493.
Okay, come take any call.
Looks real good. You're coming out of 500. What the hell?
The US Air 737 has barely touched down. It erupts in flames and crashes through Los Angeles International Airport.
I saw US Air touch down, and as he got about third way down the runway at taxiway 45, the aircraft was fully engulfed in flames. The supervisor ran past me to pick up the crash phone and alert the emergency vehicles to respond.
Aboard the flight, sheer terror.
There was a tremendous crunching sensation, and there was this extraordinary shower of sparks that shot by my window.
Good God.
Rosa Reynoso is a plainclothes officer with the airport police.
We see the aircraft engulfed in fire. My partner and I were probably about 500 yards from it.
Alert 33, runway 24 out. Affirmative, alert 33.
The initial moments were very scary, very chaotic. I remember just thinking to myself, oh God, please get some more people out here. Get me fire, get me officers, get me somebody, because this is not good.
In the tower, there's no time to dwell on what's happened. Other aircraft are still coming in to land. Controllers must direct them to safety.
Wings left 5212. Winds 240 at 8. You are cleared to land. Runway 24 right. Use caution. We just had an aircraft go off the runway in flames.
The cabin of Flight 1493 is filling with toxic smoke. Some passengers rush to a door at the rear of the plane.
I probably got 7 or 8 rows down the aisle, and then I encountered a cluster of passengers standing in the aisle, not moving. I thought to myself, there must be an opening in the front of the plane that allowed for this tremendous quantity of smoke to roll into the plane so quickly. And so I stumbled forward to the cockpit area, and there was tremendous fire on both sides of the plane. I said to myself, my gosh, there's no way you're going to get out of this airplane, David. You're trapped.
Outside, some have escaped the plane. Rosa Reynoso is the first emergency responder to arrive at the scene.
The fire was intense. It was very, very hot. I mean, almost singeing us.
She needs to act fast to help passengers away from the burning wreckage.
The passengers were trying to escape the plane from the emergency exit doors. However, the fire had engulfed the doors, so some of the people that were fine jumped out of the plane and into the fire.
More emergency personnel arrive within minutes.
Most passengers are jumping out of that door.
Some people were on fire. Some of them were scratched, cut up. Some of them had broken legs. It was pretty traumatic. And I think you just start operating on knowing that you have to do the right thing and try and save these people.
David Koch is still inside.
I suddenly saw a crack of light, and my God, it was a miracle. The crack opened up, and I suddenly realized that I had opened the galley door.
But now he faces another hurdle. He can't even see the ground through the fire and smoke.
And I said to myself, what the hell, and jumped out. I landed on the ground and then started crawling on my hands and knees away from the airplane. I had a great sense of guilt. Why did I not go back into the airplane and say, follow me? And I think if I'd gone back into the cabin, I might have passed out and fallen on the floor and died. And that's how I've come to terms with the fact that I got out but didn't help anybody else out.
As the search for survivors continues, firefighters make a stunning find.
This is Rescue 1. We've got a propeller down here in the wreckage.
The discovery of a propeller has horrifying implications.
There's 2 planes down here.
As soon as we found out that information, we started actively looking to see what aircraft, if any, were missing. So we started looking at the flight strips that were already departed, and then we looked at the ones that were still pending. And then we called the departure control, radar controller, to find out which ones they've talked to in the last 5-6 minutes.
What about SkyWest 5569?
No, we haven't heard from them.
SkyWest 569, taxiing to position hold, runway 24 left.
Okay, 24 left, position.
And hold, SkyWest 569.
Staff can account for all of the aircraft except for SkyWest 5569, a Fairchild Metroliner bound for Palmdale, California. Emergency personnel find parts of the smaller plane strewn across runway 24 left. There were 12 people on board the flight. None have survived. What's left of their plane is crushed between US Air 1493 and an abandoned building near the runway.
My first thought was, oh my God, there was someone else under there, and we didn't even realize it.
There's even more loss of life on board the larger plane. 20 are dead, 2 others are mortally wounded. First Officer Kelly has survived, but Captain Shaw has not. The disaster thrusts LAX into the media spotlight.
America's runways, according to the nation's pilots, the most dangerous part of the flight.
In the months and years leading up to the crash, increasing traffic was becoming a safety concern at Los Angeles International Airport.
The most close calls, Los Angeles International Airport. 33 near collisions over the last 4 years. That's 1 every month and a half.
The accident confirms safety issues need to be addressed. The National Transportation Safety Board sends its GO team to LAX to investigate.
It was kind of a horrific scene. The front end of the airplane was impaled on the captain's side against the building. And with close inspection, we could see parts of another aircraft underneath.
Investigators can see that the 2 planes collided at an intersection on runway 24 left.
The scenario of the accident resulted in 2 planes being on the runway at the same time. The runway was occupied. And that's something that should never happen when a landing clearance is granted.
Reducing collisions on U.S. runways is a priority for investigators from the NTSB.
We had runway incursions on the most wanted list from 1990 here at the Safety Board. And it's a major concern for the whole industry. A runway incursion is simply when an inappropriate object is out on a runway that's going to be used for a takeoff or landing.
Some of the world's worst airline disasters have taken place on runways. In March 1977, on the island of Tenerife, 583 people died when two Boeing 747s collided on the runway. In January 1990, a Beechcraft King Air 100 was struck by a Boeing 727 attempting to land in Atlanta. Later that year in Detroit, another Boeing 727 smashed straight into a DC-9 carrying 44 people.
Runway incursions occur due to some failure in the existing system. Something has happened. Some directive has not been followed. Some inattention is present in the scenario of a runway incursion.
Which one of these planes was cleared for 24 left?
Investigators need to find out why there were two planes on runway 24 left at the same time.
One of the principal objectives was to immediately see if we could find out what error had taken place that would allow that situation to occur.
Part of that answer may lie in the wreckage. But 24 hours after the crash, the investigation is at a near standstill. There's too much fuel on board the 737. Crawling through the wreckage would be dangerous.
The aircraft had about 6,000 pounds, maybe 1,000 gallons of fuel on board.
How long is this going to take?
The Saturday was spent defueling the aircraft, and that's a very slow process. That took almost all day before the fire department could declare that the scene was safe.
With airplane parts littering the airport, LAX is running at half capacity. 2 of the 4 runways are shut down. That's causing chaos for travelers. When the NTSB team finally gets access to the wreckage, they're under enormous pressure to act quickly. They must gather all the information they need so the airport can be fully reopened. Their investigation has a dual purpose. They must figure out what caused the collision. They also want to know why so many passengers got trapped and died in the burning aircraft.
We're not sure what went on. We don't have a recording of it, but there were some altercations with people trying to get ahead of other people.
Making matters worse, one of the emergency exit doors is inside the plane, partially blocking the exit.
If you follow the instructions on the card, the exit card, it will tell you to throw that exit out. This did not take place, so the right over-the-wing exit was, I would say, partially obstructed by that large hatch.
The NTSB concludes that a reduced number of exit doors made it impossible for many of the passengers to escape. With no way out, they were overcome by toxic smoke as it filled the cabin. While some investigators analyze wreckage at the crash site, others focus on air traffic control.
Well, first and foremost, we look at the communications, then we also look at the procedures within the facility and how those are applied, and were they indeed followed.
To learn more, the NTSB collects the audio tapes of the controller's communications with the planes. Investigators wonder what instructions were given to the pilots in the moments leading up to the crash. They also want to know what the flight crews were saying during those crucial seconds. Did the pilots follow their instructions? The cockpit voice recorders should provide investigators with the answer. But then Bob McIntosh gets some bad news about the SkyWest Metroliner.
No voice recorder. Great.
We recognized, looking at the onboard equipment, that SkyWest 569 did not have a CVR flight recorder installed. And that was disappointing to us.
At the time of the crash, commuter planes were not required to carry cockpit voice recorders. This means the only SkyWest conversations caught on tape are radio communications recorded in the control tower.
Okay, 24 left. Position and hold, SkyWest 569.
The two cockpit crew members would have exchanged words, would have been listening to the air traffic information that was coming into their cockpit all the time, and we recognized that that was a valuable piece of data that we lost.
Using the air traffic control tapes and just one CVR, investigators try to find out which of the two aircraft in the collision was actually cleared to use runway 24 left. The answer will raise alarming questions about the safety of all passengers flying to and from LAX.
246, are you still holding short of 47?
The investigation into the deadly collision on runway 24 left focuses on Robin Washer's conversations with the two planes involved. Investigators begin with the smaller plane.
23, taxi into position and hold.
Minutes before the accident, the pilots of the Metroliner waited for permission to take off.
SkyWest 569, taxi into position and hold runway 24 left. Traffic will be crossing downfield.
We use the tapes to try to visualize, like a local controller would, where the aircraft would be on the runway.
The pilots of the SkyWest Metroliner turned their plane onto the runway and stopped at intersection 45. They had to wait for another plane to cross the runway downfield.
Okay, 24 left, position and hold, SkyWest 569.
Okay, stop her right there.
From the air traffic control tapes, the NTSB can tell that the pilots of the Metroliner followed all their instructions correctly.
All right, let's keep going.
Responsibility for the accident must lie elsewhere. Investigators probe the tapes further. They look at Washer's communications with the US Air pilots.
US Air 1493 for the left side, 24 left.
Thank you, US Air 1493. You're cleared to land 24 left.
A US Air 1493 was cleared to land on the same runway during the time that SkyWest 569 was still sitting in position on that same runway.
Cleared to land, 24 left, 1493.
SkyWest 569, right at intersection 45. How long's it been there? 1 minute, 7 seconds.
The air traffic control tapes reveal that Robin Washer instructed both the SkyWest Metroliner and the US Air flight to use runway 24 left at the same time.
Left contact ground, point 65 when you're.
What the hell?
When we're examining the recorded voice communications, what we try to do is to put ourselves in the position of the controller. What would she have seen? What would she have heard? What would she have done?
Investigators need to know what Robin Washer was doing at the time of the crash. They look at the other flights that she had under her control.
Wings west 5006, taxi across runway 24 left.
They learned that in the moments before the collision, Washer began to lose track of some of those flights.
Is that for Philippine 102?
No, sir, hold short. Wings West 5006, taxi across runway 24 left.
Wings West 5006 was an aircraft that was on the north side of runway 24 left who wanted to cross to the south side.
Wings West 5006, ground tower.
And when she was ready to cross the aircraft, the crew did not respond.
Washer spent nearly a full minute of her time trying to re-establish radio contact with the flight crossing the runway.
Can I hear the rest of that exchange?
Wings West 5006, on frequency again. Change radio. Sorry about that.
They advised her they had inadvertently been on another frequency.
5006, you're back with me.
Yeah, we didn't mean to switch radios. We're on now.
And that created a distraction for the local controller.
Okay, I thought I lost you.
Sorry, we thought we lost you. We apologize.
Not a problem.
But investigators discover that that flight wasn't the only aircraft Robin Washer was fixated on in the moments before the crash.
Tower Wings West 5072 is ready for takeoff.
Wings West 5072?
With US Air 1493 less than a minute from touchdown, Washer hears from another Wings West aircraft, Flight 5072.
When Wings West 5072 called to say that he was ready for departure, it was obvious to us that she didn't understand who this aircraft was.
Wings West 5072, are you at 47 or full length?
We're at full length.
Okay, hold short.
Roger, holding short.
Investigators need to hear from Washer herself.
I couldn't find the flight progress strip.
They hope to learn why she didn't recognize a flight that was under her control.
I couldn't find the strip, so I asked my supervisor to help me. Francina, I need a strip for Wings West 5072.
She explains that as the pilots of the Metroliner waited on the runway for permission to take off, she was searching for another flight's progress strip. Before she could get back on track, US Air Flight 1493 crashed into the back of the Metroliner.
What the hell?
NTSB investigators now know that human error played a major role in the collision at LAX. Remarkably, when she cleared the US Air flight to land, Robin Washer simply forgot about the Metroliner waiting on the runway.
This situation that occurred is a situation that no controller wants to go through. You train your whole career for this not to happen. And when it does happen, it's, you can't even describe the feelings that you go through. A situation like this could potentially happen to anybody. We are all human.
After the accident, Washer left her job at LAX and never worked as an air traffic controller again. But investigators believe there are likely more causes to this accident than one person's fatal error.
Anytime that you do an investigation, it's easy to point the blame at one individual. What you want to do is to say, why did this occur, and what can we do to prevent a reoccurrence?
Answers to those questions begin to emerge as the NTSB examines the daily routine in the control tower in the weeks before the accident.
It was one of those, you don't know you have a problem until you have a problem.
It turns out another disaster was narrowly averted 7 months before the collision. A landing DC-10 flew just over an Airbus waiting on the runway to take off at LAX.
Los Angeles Airport has always been known as one of the #1 runway incursion airports in the system, and changes were overdue.
Controllers at LAX produced documentation showing that immediately after that close call, they alerted officials that the control tower was understaffed. They also explained that regions around the northern runways were invisible to controllers because their view was blocked by a light tower.
We went up in the tower, climbed the stairs, and asked the air traffic controllers to step aside while we sat in their chairs and looked out the window. The view that the air traffic controller was presented with had an obstruction, a light pole that produced a glare, and it was a light that lit up the airport ramp.
Robin Washer may not have been able to see the SkyWest Metroliner as it sat out on the runway. NTSB investigators look at other tools she could have used to detect the forgotten plane.
Surface radar is generally used during periods of low visibility. It is a tool by which the local controller, should they so choose, be able to visually confirm on that scope that an aircraft is indeed where it says it is.
Ground radar displays all aircraft and ground vehicles moving around the airport. But on the night of the accident, that system wasn't working.
You're holding short, is that correct, sir?
Yes, ma'am, we're holding short.
It was in constant out of service, in service, out of service, in service, and gave the management a lot of trouble.
The system was not very reliable, and we did lodge complaints to have it fixed and to upgrade the system as soon as we could.
Investigators learned that just 4 days before the accident, officials at LAX had formally asked the FAA to treat the failing ground radar with the highest priority.
The radar drive and some of the drive mechanism had some ring gears and spur gears that they had to go to machine shops and literally make that part because it would wear out on a regular basis trying to rotate the antenna.
We looked into this particular problem and learned that Los Angeles had been slated to receive a new system in 1988. However, that date had slipped, and at that time, they were not sure when they were going to get a new radar system.
With the ground radar system out of commission, and with her view of the runway impeded by blinding lights, Robin Washer's chances of discovering her error were slim. Investigators turned their attention to the cockpit of the US Air flight. They wonder why the pilots didn't see the Metroliner out on the runway and abort their landing.
Well, most of us in the pilot community would recognize that it's our job to scan that runway and find aircraft that might be out there or anything else prior to landing.
Like all planes, the Metroliner is equipped with lights to make it more visible at night. There are strobe lights on the wingtips and the tail, navigation lights on the wings, and a colored anti-collision beacon on top of the vertical stabilizer.
We were concerned about the SkyWest lighting and had to look at the flight operations manual, and we found that the operating procedure for that company was to turn on the strobe lights only after clearance for takeoff.
So no other lights were required? Okay, thank you.
The Metroliner wasn't yet cleared for takeoff, so the only lights that would have been lit while it waited on the runway were the navigation lights on the wings and tail, and the anti-collision beacon on the tail. NTSB investigators then use a helicopter to put themselves in the position of the US Air pilots as they were making the approach to runway 24 left.
We went up and we actually flew that final approach in order to verify what we thought might be the condition of obscuration.
They positioned a Metroliner on the runway in the same spot where the collision occurred.
And sure enough, we could not see that aircraft parked out there at spot 45 and 47. You just couldn't see it.
Looks real good.
The investigation determines the lights on the Metroliner were the same color and brightness as the runway lights. The plane may have been all but invisible to the pilots of US Air 1493.
You're coming out of 500.
The anti-collision beacon in particular would have been lost in a sea of lights. When the National Transportation Safety Board releases its report, controller error is determined to be a cause of the runway collision.
We're in the business of determining why something happened. You may call it a cause or causes or contributing factors, but our job ends when the next accident is prevented.
Preventing accidents on the runways of LAX would prove to be a much greater challenge than investigators could imagine. The collision between US Air Flight 1493 and a SkyWest Metroliner alarms the public. The accident seems to prove that controllers cannot safely handle the increasing traffic at Los Angeles International Airport. The NTSB investigation points to Robin Washer's failure to maintain awareness of the flights under her control as one cause of the accident. But the report also points to a failing system in the air traffic control facilities at LAX. In the months and years following the accident, improvements are made to air traffic facilities in an attempt to make the airport a safer place. The failing ground radar system is finally replaced with a newer model.
Today at Los Angeles Tower, we have the newest system out there. Each arrival or departure they're taxiing on the taxiways or on the runways have a call sign and type aircraft associated with it, so you have positive identification of all aircraft at all times.
New policies governing the way flight progress strips are handled in the tower are put in place. Ground controllers now organize the strips before they make their way to the local controller. The extra set of eyes reduces the local controller's workload. 5 years after the crash, a new air traffic control tower is built at LAX. The tower is 16 stories higher, 3 times larger, and offers controllers clear, unobstructed sightlines. New regulations concerning aircraft lighting are also put in place. It becomes mandatory for pilots to turn on all their lights before they move out onto a runway. But despite the improvements, the rate of runway incursions at LAX only goes up.
Throughout the 90s and even into the 2000s, I would describe it as a common event. LAX certainly was one of the worst airports we had for a number of incursions.
10 years after the accident, more serious runway incursions were happening at LAX than at any other airport in the United States.
They had double-digit runway incursions and serious runway incursions almost every year. And in fact, in 2007, they actually had 21 runway incursions.
In an attempt to reduce the problem once and for all, the Federal Aviation Administration begins work on a new system of runway lights to keep planes apart on the ground.
Runway status light system is a series of runway entrance lighting that we put at taxiways or takeoff hold lighting that we actually put on the runway itself.
The system is fully automatic. It uses a series of red lights embedded in the runways and taxiways. The lights warn pilots if there is conflicting traffic.
The runway status lights illuminate red, tells a pilot that it is unsafe, or a vehicle driver, that it is unsafe to either cross or enter that runway. And it triggers because there is an aircraft landing or departing. There's some other traffic on the runway. The runway status light seems to be one of the most effective systems we have for preventing runway incursions, and certainly the serious runway incursions.
In April 2009, the technology was installed at Los Angeles International Airport. Prototypes of the system have also been installed at Dallas-Fort Worth and San Diego. By 2011, runway status lights will be a key feature at dozens of airports across the United States.
The equipment we're using at Los Angeles Tower today is much better than the equipment that we used back in 1991. It's been upgraded, it's much more reliable, and it gives the controllers the tools they need to make sure that the runways are clear and to keep the aircraft moving.
Though new technology can never guarantee 100% safety, the improvements at LAX have restored public confidence in the airport, even among those who survived Flight 1493.
I spent a couple of days in intensive care at a local hospital, and I had nightmares, by the way, following my release from the hospital for quite a number of days. But I'm doing fine now. I have no problem with getting on airplanes and flying, and I've got great confidence in the airline system.
35,000 feet above the Sea of Japan,
Korean Air 007, unreadable.
We're experiencing rapid decompression. Descent to 10,000.
the pilots have lost control of their plane.
Speed brake is coming out.
A 747 with 269 people on board plunges towards the sea.
Within hours, the story began circulating in Washington that the Soviets had been involved.
This shocking incident escalates tension between two bitter rivals. The investigation is mired in secrecy and deception. It's up to investigators to find the answer before the crash of a passenger jet leads to an all-out war.
Emergency descent. Put the mask over your nose and adjust the headband. Emergency descent. Emergency descent. Put the mask over your nose and adjust the headband. Emergency descent. Put the mask over your nose and adjust the headband. Emergency descent. Put the mask over your nose and adjust the headband.
It's just after 2 in the morning aboard KAL Flight 007.
Korean Air 007, position over Nippy, estimating NOCA 1826132.0.
After a brief layover in Anchorage, a Korean Airlines 747 is on its way to Seoul. The marathon flight originated in New York 13 hours ago. Captain Chun Byung-in has nearly 11 years' experience flying for Korean Airlines. Before that, he served 10 years in the Korean Air Force. This leg of the flight is a 6,100-kilometer journey over the North Pacific. Once the plane is in the air, there is very little for the pilots to do.
Ladies and gentlemen, we'll soon be serving breakfast before we land in Kimpo, which will be in about 3 hours.
Many of the passengers plan to take connecting flights to other destinations after landing in Seoul. Mary Jane Hendry is heading to Japan to start a new life.
My sister Mary Jane found a job and she'd gotten hired by this Cara company. She was exactly the kind of person that they needed for their company in Tokyo. So she was leaving to embark on this new stage of her career.
Just 15 minutes behind them is the plane's sister flight, KAL-015.
Korean Air 007.
Go ahead, Korean Air 015.
What are you doing?
The flight crews chat to help pass the time.
Go see the leaves.
We're experiencing an unexpectedly strong tailwind.
How much of a tailwind?
35 knots from 040.
In an effort to conserve fuel, the crew decides to take the plane to a higher altitude.
Tokyo Center, Korean Air 007.
Korean Air 007 Tokyo.
Korean Air 007 requests climb 350.
Roger, stand by. Korean Air 007, climb and maintain flight level 350.
Roger, Korean Air 007, climb and maintain flight level 350.
Then, without warning, the plane is out of control.
What happened? Guard throttles.
Landing gear.
Landing gear.
The crew extends the landing gear in an effort to stop the plane from climbing.
Altitude is going up. Altitude is going up. Altitude is going up. Speed brake is coming out. I can't descend.
This isn't working. This isn't working. Engines are normal, sir.
Is it rapid decompression?
Tokyo Center, Korean Air 007.
Korean Air 007 Tokyo.
We are experiencing rapid decompression. Descend to 10,000.
Korean Air 007, unreadable, unreadable. Radio check on 10048.
Stand by, stand by, stand by.
Headband. Emergency descent.
Korean Air 007 Tokyo.
Korean Airlines Flight 007 and all 269 people on board have vanished.
Korean Air 015, would you attempt to contact Korean Air 007, please, and relay position?
All efforts to contact the flight have failed. Tokyo makes calls to other radar stations in Japan and Korea.
I cannot contact Korean Air.
A call is even made to a radar facility in the Soviet Union. Relatives nervously await news of the missing flight.
The company that Mary Jane was going to work for, they apparently had phoned and said Mary Jane's plane hadn't arrived and that something had perhaps gone wrong with the plane, but at that point we didn't really know anything.
There was concern that it had been either forced to land or crashed, or within hours, the story began circulating in Washington that the Soviets had been involved.
As the world waits for news about the incident, US military officials make a horrible discovery. At a top-secret surveillance facility, they've been monitoring Soviet transmissions. It appears the unthinkable has happened. At the time of the flight's disappearance, US soldiers heard what they thought was a routine Soviet training mission.
При нарушении государственной границы приблизиться к цели и уничтожить.
It doesn't seem possible that the Soviets would actually shoot down a passenger plane. But American officials have little doubt. The next morning, US Secretary of State George Shultz delivers an unusually blunt statement.
The United States reacts with revulsion to this attack. Loss of life appears to be heavy. We can see no excuse whatsoever for this appalling act.
It couldn't be. It couldn't be. How could they all just perish? What do you mean? There must have been a reason.
1983 is the height of the Cold War. Russia and much of Eastern Europe are united by communist ideology. Ruled with an iron fist, the Soviet Union is locked in a bitter political struggle with the West.
Relations were bad, but no one really knew how bad, how dangerously bad they were.
Initially, Soviet officials deny responsibility for the KAL disaster.
The story came out of Moscow was that the plane appeared, we intercepted it, tried to make it stop, it didn't, it flew away. That was the first story.
But soon they reverse course and come clean. A Soviet fighter jet did in fact shoot the plane down, but they insist the attack was justified.
The Soviet view was that it was on a spy mission, perhaps carrying instruments, cameras, recorders, and so forth.
The Soviet Union claims Flight 007 entered highly restricted airspace under orders from the US government. But the US insists KAL 007 was a routine passenger flight. The dispute only heightens political tension.
In terms of an actual shooting war, the closest points that we may have come were in that year, both before and after, when both sides, particularly the Soviet side, though, was expecting an attack.
The KAL disaster would put NATO nuclear disarmament talks in jeopardy. The Soviets would ultimately walk away. The nuclear threat is growing. Under such circumstances, the need for an impartial inquiry is urgent. The UN calls on the International Civil Aviation Organization.
ICAO offers a neutral investigation, an investigation team that can deal with all parties involved in a neutral way.
Kai Frostel joins the international team of investigators that will try to uncover the truth behind the destruction of Flight 007. With two superpowers squaring off, they're under pressure to find answers, and find them fast. KAL 007's flight plan should have kept it well away from Soviet airspace. Either it was shot down over international waters, or the flight had strayed off course. Figuring out which is the first priority for investigators. But they face a huge obstacle. The plane's black boxes are still missing.
The lack of flight recorders, data recorder, cockpit voice recorder, that's significant in an investigation.
The Americans joined forces with South Korea and Japan in the search for the crucial devices. But the three Allied nations are not the only ones searching.
On September 1st, we got an order to go to the place where the Boeing fell and take part in the search for the Boeing 747.
It's a race to find the black boxes. The Americans know they may never get the truth if the Soviets find the boxes first. Each side accuses the other of dirty tricks.
The U.S. did formally complain that the Soviets would either sail across U.S. ships, that they would drop false pingers to deflect listening devices away from the true pinger.
The Soviets claim Flight 007 was flying in Soviet airspace over Sakhalin Island when they shot it down. If that's true, the aircraft was well outside its designated aerial corridor, a route known as R20.
Across the North Pacific, there are various routes that are labeled that R20 was the one closest to Soviet airspace. The Red Route 1 was a nickname for it. It was the one closest. So it was known to be, or should have been known to be, a route that you took extra precautions on.
Investigators get their first hint that if the crew was flying in restricted airspace, they didn't know it.
The coordinates they were reporting, it put them on course.
The Tokyo air traffic controller who last communicated with Flight 007 tells investigators that all seemed normal.
Korean Air 007, position over Nippy, estimating NOCA 1826132.0.
The crew reported they were flying the R20 route. But as with every other flight over the Pacific, 007 was beyond Tokyo's radar range. The controller could only rely on the pilots to verify their position. Perhaps they were mistaken about where they were. That possibility becomes more likely when investigators talk to the crew of the Korean Airlines flight that was just minutes behind Flight 007.
Tell me about the exchange with Flight 007.
The captain of the second flight recounts an odd conversation with the 007 crew.
We're experiencing an unexpectedly strong tailwind.
How much of a tailwind?
35 knots from 040.
We still have a 15-knot headwind.
Could he be getting a headwind if he was here?
It would be almost impossible for one flight to have a tailwind and the other a headwind. Something doesn't add up. But with the black box still missing, investigators have no way of knowing where KAL 007 actually was at the time of that exchange.
That made it very difficult in the way that we had no direct information that I would normally have as an accident investigator.
Frostel gets more information from an unlikely source, the US military. In a rare move, US officials share highly classified surveillance data from the night of the shootdown. A top-secret technology called passive radar can track the movements of every military and civilian plane around the globe. What it reveals about KAL 007 is stunning. The plane was way off course. For almost its entire journey across the Pacific, the flight had been drifting north. By the time it was shot down, Flight 007 was 560 kilometers, or 350 miles north of where it should have been, and had already flown in and out of Soviet territory. The Soviets were telling the truth.
And then it becomes a question of determining why was it off course that much.
To find the answer, investigators turned their attention to the navigation system on board the 747. It's called INS, the Inertial Navigation System.
The INS that was used on this airliner, like most in that time period, had an accuracy of about half a mile of drift per hour. Very accurate. It would get you where you wanted to be.
The system relies on coordinates, or waypoints, entered into the flight controller.
The way it works is that there is 9 waypoints that you put in. That's the way you program it.
59 degrees, 18.0 north.
Waypoints are essentially GPS coordinates that also have one-word names, like Bethel, Neva, or Nippy. Flight 007's INS should have been programmed to find and follow those electronic guideposts to Seoul.
18.0 north.
At 8:49, turn left heading 270.
Perhaps there was some last-minute change in the flight plan. Kai Frostel listens to the pre-flight conversation between the crew and the tower in Alaska.
Net at 473, turn right.
Korean Air 007, climb and maintain flight level 310.
Net at 473, turn right heading 0.
It was total routine from the beginning to the end. There was nothing exceptional with the takeoff or the taxiing to position, the preparation for the flight.
After leaving Anchorage, the 747 flew out over the Pacific just as planned. But it never made it to the first waypoint. Instead, it drifted off course for more than 5 hours. Hope of uncovering the reasons why begins to fade. A 10-week effort to recover the flight recorders has turned up nothing. The search is called off.
The actual aircraft, where it was and how many pieces it was, remained unknown.
With the investigation stalled, Frostel turns to the plane's manufacturers.
The US and Boeing offered to simulate the route that we knew Korean 007 had flown. We went over to Boeing in Seattle and Boeing carried out the simulation.
Waypoint number 2, 59 degrees, 18.
Retracing Flight 007 steps in a simulator leaves them with a few possibilities. One is that a mistake was made while entering the coordinates into the INS.
60 degrees, 47.1 north.
Normally the co-pilot would insert the waypoints and the captain would check that the correct digits have been put in.
60 degrees, 47.1 north, check.
Misprogramming the INS at the gate could have taken the plane over the Soviet Union.
Okay, let's try the flight in heading mode now.
A second, less likely possibility is that after programming the waypoint navigation system, the crew may have failed to turn it on.
After takeoff from Anchorage, the aircraft would have used a constant magnetic heading to get to the route.
It's a standard procedure to begin a flight using a magnetic compass heading for direction. Soon after takeoff, pilots must activate the navigation system so it can lock on to the first waypoint.
And if it was forgotten in that constant magnetic heading, it would continue over Soviet airspace.
The magnetic heading would have kept the plane flying in the right direction, but along a very different route than the one planned. Captain Chun was a distinguished pilot with years of experience. Forgetting to switch the autopilot to INS mode would have been an astonishing error. At this point, Frostel can only speculate why Flight 007 was off course. But what's even harder to understand is why the Soviet Union would risk starting a war by shooting a plane down.
The Soviets resorted to deadly force to punish this intruder. It's like shooting the paperboy in your front yard at night because you think he might be breaking into your house.
What could prompt such a response from the Soviets? Investigators get their answer from the US military. Though Flight 007 may not have been on a spy mission that night, another plane was, a U.S. Air Force RC-135.
They were tracking an RC-135, which was doing very, very slow figure eights off the coast with its own listening devices, waiting for a Soviet missile test.
The spy plane was near the Soviet border in the path of the KAL jetliner. When their paths crossed, the two planes may have been indistinguishable on Soviet radar.
When 007 came in over Soviet airspace, the Soviet Union assumed it's an RC-135.
Along came this intruder, and they just fell into the patterns that they had prepared in advance for such an intruder.
On violation of state border, approach target and destroy.
But disturbing questions remain. Did the fighter pilot get close enough to see the target with his own eyes? Did he know it was a passenger jet? Requests to speak to fighter pilot Gennady Osipovich are refused. And for the time being at least, those questions are left unanswered. In December 1983, less than 4 months after the disaster, ICAO releases the findings of the investigation. Though lacking hard evidence, the report concludes Flight 007 strayed into Soviet airspace by accident, due to pilot error in operating the navigation system.
I would almost call it the best guess based on all the work and the factual information we had in 1983.
For them to summarize that the plane was there by accident, as far as I'm concerned, that's not the answers we wanted to hear, and we believe that there was further investigation to do.
The key to this mystery remains locked inside the plane's black boxes, which are assumed lost forever beneath the sea. In the months following the KAL disaster, unidentifiable human remains wash ashore in northern Japan. Small pieces of wreckage are also found. Investigators have no doubt that the plane was completely destroyed.
We don't know where their bodies lie. There was clothing that washed up on the shore, her ID washed up on the shore of Japan. Of course, getting that ID back was, at least we had something.
Like the victims' families, investigators have no clear idea where Flight 007 went down. But there are some people who do. Top Soviet officials are hiding the fact that 1 month after the incident, not only did they find the wreckage, they also found the all-important black boxes.
It was a big pile of debris. They took down this pile with their bare hands until they found the black boxes. There were 2 of them.
But the Soviets keep the boxes to themselves. The information is kept locked away. Until nearly 10 years later, after the turn of the decade brings a jubilant end to the Cold War, Glasnost ushers in a new spirit of openness in Russia. Eager to break with the past, the new administration in Moscow decides to go public.
The actual unveiling of the data recorders and black boxes was a total surprise. And suddenly this new material promised some real answers.
So I knew they're gonna tell me something. I wanted to have the facts from the tapes and then see how does those facts compare to what we wrote in 1983.
In 1992, during official ceremonies in Seoul, Russian leader Boris Yeltsin hands over the long-awaited flight recorders.
I was approached by KGB general, and he told me that you probably don't know me, but I have had the recorders for 10 years. I had them in the safe in my office. I knew it was a big international secret. It bothered me tremendously. Every day when I came to the office and I looked at my safe, and I knew the recorders were there. He told me, you may not understand that this is the happiest day in my life.
Kai Frostel is asked to lead the new team of investigators based in Paris. And as a clear indication that the times have changed, Vladimir Kaufman, a Russian avionics expert, joins the team.
Он, так сказать, ничем особо не выделялся.
At the time, I was working at the Civil Institute of Aviation and was an air crash investigator. This was an international investigation of a very high level.
Очень высокого уровня.
Their first task is to make sure the black boxes are authentic.
There was a high suspicion in a lot of quarters that the Russians or the Soviets had tampered with the tapes or had made bogus tapes. And so we had to 110% validate the authenticity of the tape. They had seals on them. I remember wax seals on them. The photographs were taken, the seals were cut.
Investigators confirm that the CVR handed over by the Russians is the same box that was installed on Flight 007.
They opened them and looked at them and validated the serial numbers, validated the model numbers.
Now that they know they have the right boxes, investigators need to make sure they have not been tampered with. Suspicion soon arises.
During the cleaning process, they noted that there had been some breaks in the tape and had been spliced by the Russians.
It is not uncommon for a tape to break during the impact of a crash. But distrust of the former Soviet Union runs deep.
First, they examined these areas of the splices where it had broken, and they did that on this high magnification photograph. One of the techniques that the French had that I hadn't seen before, that wasn't used in the United States, was a photo analysis machine. They could do this with this optical high magnification. They could actually see the magnetic waves.
The test confirms that no data was added or removed from the cockpit voice recorder when it was spliced together.
565, what was the altimeter again?
Finally, investigators can listen to the tape, confident that every word is authentic.
What? It's already time for breakfast.
What do you know?
Let's eat later.
But all they hear is idle banter from the crew.
I heard there's a currency exchange at the airport.
What kind of money?
Dollars to Korean money.
It's in the domestic building.
There is not a word on the tape to suggest the crew was on a spy mission.
Just a totally routine conversation, and either these guys are the most cold-blooded actors and falsifiers ever, or they really were totally clueless about where they were. Sadly, I think the latter's the case.
It seems unlikely that KAL-007 was on a spy mission. but it was caught flying over Soviet territory. Investigators have long suspected that the crew either misprogrammed their navigation system or left it in the wrong mode, set on constant magnetic heading. The flight data recorder finally provides the definitive answer.
The data revealed that the aircraft was on constant magnetic heading from soon after takeoff from Anchorage to the end. There was no deviation whatsoever in the magnetic heading.
The crew of KAL 007 never activated the waypoint navigation system.
Gear up.
Landing gear up. Now passing 500.
It seems they simply forgot a basic step in their standard flight procedure.
The INS was functioning properly, had been loaded properly, and was counting along the route where it was thought it was supposed to be. But the autopilot was not following the INS commands. Instead, it was following a compass mode.
So it's only telling them where they're supposed to be.
Investigators learned that even though the plane was following a compass heading and not the waypoints, the computer would have continued to display their intended waypoints even though the plane was nowhere near them.
Korean Air 007, position over Nippy, estimating NOCA 1826132.0.
This may explain why the crew never noticed their mistake. The crew also didn't notice a key indication that they were badly off course.
We're experiencing an unexpectedly strong tailwind.
How much of a tailwind?
35 knots from 040.
The fact that they were experiencing completely different weather patterns to a plane supposedly minutes behind them should have alerted them to the problem.
Now, there's a point where you see him teetering on the brink of realizing something is horribly wrong. He's talking to the pilot behind him, and the winds are almost 180 degrees apart, and there's a pause, and Chun is somewhere in his mind, as he's a pilot, and he has the instinct, this is odd. Is it a clue to something I should look into? And he doesn't. And at that point, he might as well pull the gun out and put it to his head.
It was human error. A complacent crew in the middle of the night had their flight computer on the wrong setting, and then didn't notice they were straying off course.
Everybody makes mistakes sooner or later. Good pilots make mistakes. Not so good pilot makes mistakes. We're all making mistakes.
When investigators combined the conversation data from Flight 007 with intercepted Soviet transmissions, they get a detailed picture of what went wrong on September the 1st, 1983. The pilots believed they were on course. But 3 hours into the flight, their magnetic heading took them into Soviet airspace over Kamchatka. The Soviet military had been tracking a US reconnaissance plane.
There was a real American spy plane. It was there. There were two planes that looked alike. When KAL penetrated the border, the perception was that this was the plane.
As the passengers sleep through their long journey, the Soviets scramble fighters to intercept the plane.
The identity of the plane was just not known. The clues that it was a lost civilian airliner, well, might have been there. The clues that it was a 135 didn't add up, but the Soviets involved didn't have time to think it through.
Target traveling at high speed and approaching border.
But the fighters are not fast enough. The plane leaves Soviet airspace and continues along its heading to Seoul.
They figured that they'd just been spooked, but that was all over. Unfortunately, for everyone involved, it wasn't.
The airliner is just seconds from flying over the island of Sakhalin.
So Sakhalin was prepared.
KAL Flight 007 enters Soviet airspace for the second time.
Ladies and gentlemen, we'll soon be serving breakfast before we land in Kimpo, which will be in about 3 hours.
Target traveling at high speed and approaching border.
Target is on your heading.
I can see it both visually and on the screen.
Major Gennady Osipovich, the lead fighter, makes visual contact with Flight 007.
Give warning burst with cannon.
But the warning shots go unnoticed.
Take up position for attack. Approach target and destroy.
Roger, locked on already. Executed launch. Target is destroyed.
The fighter pilot believed the 747 was an enemy spy plane. It takes nearly a decade after he shot down KAL 007 for that pilot to tell his side of the story. Investigators have long wondered what Major Gennady Osipovich saw and did after he was ordered to intercept an intruding aircraft in 1983. After nearly 10 years and the collapse of the communist regime, he finally tells his side of the story.
I saw the plane. It did look like a civilian plane because there was a flashing light on its tail and one on the top. But you can disguise any plane like this. You can put a flashing light on and you've got a civilian plane. So I did not have any thoughts about this.
Give warning burst with cannon.
When warning shots are fired, they usually include tracers, which are like flares and are easily seen. However, Osipovich had no tracers loaded in his cannon.
They're supposed to load tracers, just no one had shipped them any for the last 6 months, so they weren't there.
But even without the tracers, Osipovich thinks the 747 crew should have seen him.
As I caught up with him, I was flying like this, and he was flying like that. How could he not turn around and see me? I was flying with lights, everything was according to protocol. He should have seen me.
And then a horrible coincidence seals the fate of 269 people aboard the flight.
Korean Air 007 requests climb 350.
Korean Air 007, climb and maintain flight level 350.
Like a car going uphill, a climbing plane slows down. But to the fighter pilot following the 747, this is interpreted as an evasive maneuver.
He decreased his speed so that I could either pass him or fall, one of the two. So that's how I knew that he's an enemy intruder.
That convinced him that it was not a civilian plane and that he was in danger.
My only thought was to catch and stop. This is what we were trained to do. I fell a little behind him and banked down, made a snake maneuver, put some distance between us, because otherwise, the rockets would not have locked on.
He's running out of time because the airliner was approaching international waters.
Take up position for attack.
Roger, locked on already. Executed launch.
Osipovich fires 2 air-to-air missiles. They travel 2,000 kilometers an hour towards the jetliner. One of them explodes near the tail, damaging vital controls and hydraulic lines. The warhead also tears a hole in the fuselage, causing a rapid decompression in the cabin.
I saw the first explosion right under the tail, and that's it. The lights of the trespasser went out, and I went home.
Emergency descent. Put the mask over your nose and adjust the headband. Emergency descent. Put the mask over your nose and adjust the headband.
In the time that they lost pressurization to a certain point indicated that the hole would have been approximately 1.75 square feet.
The crew managed to fly the crippled plane for several minutes.
Immediately after the missile impact, the aircraft climbed to flight level 380, and then it descended about 5,000 feet per minute.
The stricken jetliner plummeted towards the Sea of Japan, with most of its passengers likely still conscious.
And that's when the recording stops. Our determination was that the airframe probably broke up at that point.
To this day, Gennady Osipovich is convinced he shot down a spy plane.
I knew they wouldn't order me to intercept if it was a civilian plane or cargo plane. Only if it was a trespasser.
We weren't blaming him, but some families did. They certainly did. They said it was his fault, and he pressed the button, and he shot them down, and they were looking to blame somebody.
It was clear that he was living with what he had done, and what he had done in order for him to live and to sleep was to believe that it was a spy plane, there were no passengers on board, that he had not killed 269 people. And that's the way he wants to believe it, and I'm not going to blame him for wanting to believe that.
In 1993, Kai Frostel has the evidence that he sorely lacked when he issued his first report. He can prove how the Korean pilots blundered and ended up off course, and how the Soviet pilot interpreted the situation. The destruction of Flight 007 is ruled an accident. Frostel recommends that all passenger planes be equipped with a clear indicator that the autopilot is in heading mode.
The tragedy of 007 is that it didn't have to happen. It was not inevitable. It was a series of accidents, a series of misunderstandings, a series of bad decisions that had been primed ahead of time.
When my sister Mary Jane said goodbye to me at the airport, she hugged me so tightly. And I said, Mary Jane, I feel like I'm never gonna see you again.
Korean 007 has had a great effect on my life. It has been close to my heart. That has been very sad for me. My sympathy and condolences all these years have gone out to the families.
New York City's LaGuardia Airport, March the 22nd, 1992. A commuter plane with 51 people on board tries to lift off the runway.
Rotate.
But the pilots can't get it to climb.
They knew they were in trouble, but they were fighting all the way to the end.
US Air Flight 405 plunges into the icy waters of Flushing Bay. 27 people die. For US investigators, it's an open and shut case.
This accident was not a huge surprise to us.
But Canadian investigators are stunned. They know the New York accident should never have happened.
My reaction when I heard about it was, my God, it's Dryden all over again.
3 years earlier, an exhaustive investigation into a crash at a remote northern airport had identified a killer and spelled out ways to keep it from striking again.
Certainly, if they had followed the recommendations in my report, The F-28 crash at LaGuardia could have been averted.
The LaGuardia accident makes one thing clear. The right people never got the warning. March the 10th, 1989. It's 11:39 a.m. at Dryden, Ontario's airport. Like snowfalls, as Air Ontario Flight 1363 stops in the remote northern community on its way from Thunder Bay to Winnipeg. The passengers stay on board while the plane is refueled. For flight attendant Sonia Hartwick and the crew aboard the Fokker F-28, it's been a frustrating day of delays.
Big, fluffy, white snowflakes at this time were falling gently to the ground, and it was very, very gray. And I thought, I guess this means we're going to be delayed again.
I can't see us making it to Winnipeg on time.
It's Friday, the beginning of March break. Already an hour behind schedule, another delay could jeopardize the vacation plans of many of the 69 passengers and crew.
There was a lot of families traveling on board with plans. Most of them were going skiing, and so they were very concerned about meeting their connections in Winnipeg.
Kenora Dryden, it's Ontario 363.
Ontario 363, Kenora. We've got quite a...
As First Officer Keith Mills checks on weather conditions, Captain George Morwood returns from making a phone call inside the airport.
It's getting worse. What's the latest?
And it won't clear till late afternoon.
Check that. Quite heavy snow. Looks like it's going to be a bad one. It's still within our takeoff limits.
Well, that's good. We got a lot of people who want to make their connectors. Let's hope it holds.
Temperatures hover around freezing. Visibility is decreasing. If the flight doesn't leave soon, it could be grounded indefinitely.
Dryden is a very small city. It's a very remote part of Ontario.
With a population of about 6,500, the isolated community lies halfway between Thunder Bay and Winnipeg. Harsh Canadian winters with bitter cold reaching -35 degrees Celsius are the norm here. It's not the place to be stranded in the middle of a snowstorm. Royal Canadian Mounted Police Officer Don Crawshaw and his partner are escorting a prisoner to Winnipeg.
When we did a criminal check on the prisoner before we left, he came up as a violent person. So 2 of us have to go with him. He was wanted in Banff on a fraud charge, and that's what he was being brought back to Alberta for.
Hey, no smoking and seatbelts.
On.
Instruments.
Syncs. Cross-check.
Captain Morwood uses the power of engine number 2, already running, to fire engine number 1. Morwood and Mills are both highly experienced pilots. However, they've each flown fewer than 100 hours in the Fokker F-28. The multi-million-dollar aircraft is the first Air Ontario jet to serve the remote Northern Ontario region. 24 minutes after landing in Dryden, Flight 1363 is ready to leave.
Inform Kenora, we're rolling.
We're fired up, taxiing for departure, requesting airways to Winnipeg.
Hang on a sec, guys. Is there a chance that plane can hold? We're having some bad weather up here.
An approaching aircraft's urgent request to land
Unbelievable.
gives Captain Morwood little choice. He delays takeoff.
Okay, 363's holding short of the active.
We are going to be a few moments until a small plane lands safely. We're sorry, folks. This just isn't our day.
In the 2 years that I had flown with Air Ontario, I'd never come across anything like this before.
The Cessna 150 lands safely, clearing the runway for Flight 1363's departure.
Tell them we're going immediately.
Kenora, Ontario, we're taxiing out at this time, 363 Dryden.
Finally, an hour behind schedule, the plane taxis to runway 29.
As we're going down the runway to position for takeoff, a blanket of snow was falling and I couldn't see the tree line anymore. It was like looking through a sheer.
Folks, we're sorry for the delay. Flight attendants, please be seated for takeoff.
At 12:09 p.m., Flight 1363 is ready for takeoff.
Advise Kenora, we're ready to proceed.
And Kenora, Dryden, Ontario, 363 is about to roll 29 at Dryden.
Ontario 363, Kenora, roger.
Captain Morwood performs a brief engine run-up, heating the engines to rid them of any accumulated snow and ice. Then he begins his roll down the runway.
When we're taking off, I'm usually very quiet and focused, meticulously going through a checklist in my own mind. What would I do in the case of an emergency?
B1.
The F-28 reaches its takeoff speed.
Rotate.
80 knots.
Our takeoff was very slow and sluggish, like a slow, sluggish person running up a hill.
Clearly, there's something wrong. The F-28 struggles to get airborne.
We cleared the trees. The plane started shaking.
I thought, oh my God, we're gonna crash.
That's when all hell broke loose. If you can equate to being in a Mixmaster, that's what the plane felt like at the time.
There's this dip to the left and then dip to the right. The pilot's trying to get this plane up.
Then all of a sudden there was a power burst. The plane seemed to stabilize itself.
You could feel that the pilot's trying to get control of it.
But a few seconds later, it became a Mixmaster again.
I yelled out, emergency, grab your ankles, get your heads down.
Grab your ankles, get your heads down!
And I kept yelling that, and then I assumed my brace position. You could hear people screaming and yelling. There's loud, horrible sounds. We are clearly crashing.
The pilots are helpless. 49 seconds after lifting off, Air Ontario Flight 1363 crash lands in the bush, 950 meters west of runway 29.
There was carnage of the aircraft all over the place. I didn't know where I was. And at that point I thought, oh my gosh, I'm alive. I'm still alive, that this is all happening so quickly.
When we crashed, we came down on an angle. It ripped the right side of the plane open, and that's how we got out, or else we probably would have never gotten out. Now, the prisoner was still in handcuffs, so I reached over and I took the cuffs off of him there, but he never left me. And then we exited the aircraft.
There's fire all around, there's explosions. I'm thinking, oh my God, we're full of fuel.
Guys, come this way.
And I started yelling, come this way, for people to follow my voice.
Come this way. Come on.
Passengers scramble for safety before the fire spreads. 45 people survived the accident, but 24 people do not, including Captain Morwood and First Officer Mills. Emergency crews rush to the crash site deep in the woods. The injured are taken to hospital in Dryden.
I was very concerned because I kept looking at the wing all the time. I thought there was a lot of snow.
Well, I didn't notice anything wrong going down the runway. Like I said, it was just when we started hitting the trees, I knew there was something wrong.
Within 24 hours, a team of investigators from the Canadian Aviation Safety Board arrives at the scene.
You're going there, hopefully with the idea that you can find out what happened, why it happened, and how do you prevent it from happening in the future. We walked the entire path of the airplane to the threshold of the runway, and then we walked the flight path of the airplane right to the crash site. That was the first thing that I did. I wanted to document what I was seeing by photographing. When you walk in on an accident site like that, there are two things that overwhelm you. The smell of aviation jet fuel and the smell of death.
The trees just past the end of runway 29 give investigator David Roa and his team vital clues about the F-28's failed flight.
What happened was the airplane went off the end of the runway in what we would call ground effect and just stayed at that height, simply clipping the tops of the trees.
Look at how these treetops have been clipped off.
It didn't ever fly. You've got 24 people that died. You've got 2 pilots that died and a flight attendant that died. And they died, for the most part, trying to do their job. So you really want to do them justice, but you also have to be fair. And if there were mistakes made, mistakes have to be fixed.
From the rear of the fuselage, investigators recover the F-28's 2 black boxes, the flight data recorder and the cockpit voice recorder. The devices are designed to withstand temperatures of 1100 degrees Celsius for up to 30 minutes. Investigators are frustrated to learn that the mylar tape from the recorders has suffered extreme heat damage. It's estimated the black boxes were scorched by an 1100-degree inferno for at least 90 minutes, far beyond their limit. The data is unrecoverable.
That was a big blow to us because now you have to try and gather information and try and establish that it's factual by independent routes.
We were just about to leave Thunder Bay and they gave us 10 new passengers.
Investigators must now rely heavily on eyewitness reports to reconstruct the events leading up to the doomed takeoff. They learned that the F-28 began its day in Winnipeg and was scheduled to fly a return route to Thunder Bay and back with a stopover in Dryden. But in Thunder Bay, plans changed. The cancellation of another flight forced the crew to pick up 10 additional passengers.
And when they did their calculations, they realized that we were overloaded and something had to come off.
All right, let's offload some fuel then.
They ended up removing fuel in order to be within the proper weight.
Dispatch, Ontario 363.
So the flight was delayed an hour.
The extra weight of the new passengers left the crew no choice. They had to unload fuel to lighten their load. That meant when they arrived in Dryden, they needed to pump in more than the usual amount of fuel for the final leg back to Winnipeg. Roa wonders if the change in plans somehow led to a miscalculation of the weight and balance. Was the F-28 too heavy for takeoff? He then uncovers a puzzling detail. The plane's weight and balance form for the takeoff from Dryden was never collected as required. It burned in the fire. Roa is forced to use Air Ontario's standard averages to calculate passenger and baggage weights. The data, combined with the airport's fuel records, allows him to estimate the plane's gross takeoff weight.
We knew how many people we had on board. We knew how many bags we had on the airplane. And we knew what our fuel load was.
He estimates the F-28 weighed between 62,000 and 64,000 pounds.
And the airplane's max takeoff weight was 65,000 pounds, and so we came to the conclusion that the airplane was not overweight.
The cause of the crash remains a mystery. 18 days into the investigation, the Canadian government appoints Justice Virgil Moshansky to lead a more wide-ranging inquiry into all aspects of the aviation system that might have contributed to the Air Ontario tragedy.
The government was looking for an experienced trial judge, and preferably one who had an aviation background.
Moshansky is an experienced pilot with 13 years on the bench. He will work closely with crash investigator David Roa and aviation consultant Frank Black. The new team's first step, assessing the plane's technical systems.
The electrical system, the hydraulic system, the fuel system, all of these systems are looked at both in terms of what is their history leading up to the accident and what remnants are remaining at the crash site that can be examined.
Clues to a possible system failure arise when Sonia Hartwig recalls a troubling event aboard the same plane just days before the fatal crash.
I think it was Monday or Tuesday. When we took off, there was this smoke that filled the aircraft, and there was this horrible smell. I thought, oh my God, we have a fire in the lab.
But there was no fire in the lavatory or anywhere else in the cabin.
They told us that apparently it had something to do with oil sitting in the APU system. So every takeoff that day, this would happen.
The auxiliary power unit is a generator that provides the power needed to start the engines. Did burning oil in the APU somehow cause a fire and ultimately doom Flight 1363? Roa searches the week's journey log for any mention of the auxiliary power unit. He makes a surprising discovery. The APU wasn't working on the day of the crash. It couldn't possibly have caused the fire. But the inoperative power unit may still have played a role in the tragedy. Investigators learned that it forced the crew to make a risky decision in Dryden.
Blown to the connectors. Let's hope it holds.
Normally, the captain would rely on the APU to restart his engines after shutting them both down for refueling.
But if he couldn't use his APU, he couldn't shut his engines down.
That meant Flight 1363 had to be refueled with one engine still running.
Captain Morwood is in a situation where he's got a hot refuel with passengers on board the aircraft. He's got to keep an engine running to refuel the airplane.
Hot refueling isn't against regulations, but the risk of a fuel spill makes it potentially dangerous. In Toronto in 1973, a maintenance person was killed when an Air Canada DC-8 jet was consumed by fire during refueling.
Hot refueling is not a normal practice.
Could the hot refueling have caused some kind of damage to the engines? The Dryden Airport manager, a former military pilot, suspects there was trouble with the plane's engines. He tells Roa he saw the takeoff from his office and heard a sharp, explosive noise just as it disappeared from view. To him, it signified a flameout or engine failure.
I thought, this is going to be a high-profile and potentially controversial investigation. And the only way to ensure that the truth stands up is to have hard evidence from the aircraft accident. And so we took the airplane completely and we put it in our lab in Ottawa.
Anything?
With signs pointing to engine failure as the cause of the crash,
strip it down.
Roa orders extensive engine testing.
Those engines were examined in detail for damage.
Roa finds the F-28's two Rolls-Royce engines suffered only minor structural damage. There's no evidence of an engine fire, nothing at all to suggest the engines had failed. With little physical evidence to explain the failed takeoff, investigators are back to square one. To solve the mystery, they comb through survivor and eyewitness statements. A common thread emerges.
They said in their witness statements there was snow and ice on the wings when the airplane attempted to take off.
ROA studies weather charts for clues.
We had very good meteorological information.
The charts show that during the half hour the F-28 was on the ground at Dryden Airport, visibility shrank from 4 kilometers to less than 1 kilometer because of the snowstorm.
And although we may find other reasons, for sure, snow and ice on the wings was a factor in this accident.
Sonia Hartwig tells investigators about an unusual sight during takeoff.
As we took off, I noticed that the wings just became a solid sheen of gray, shiny ice.
Investigators consult the F-28's manuals to study its anti-icing systems. They find that only the wing's leading edges are protected.
The aircraft had heated leading edges on the wings.
I wonder if the anti-icing system was working.
And the heat was provided by bleed air from the compressors on the engine. They found the valves that allow the compressed air access to the leading edges. And they tested the valve to see if it functioned, and it did.
The anti-icing system was working. But since it only heats the leading edge, it likely didn't clear ice that formed on the surface of Flight 1363's wings. Investigators suspect that snow and ice buildup, what experts call wing contamination, may have played a major role in the crash. To verify that suspicion, Roa and his team meet with engineers from Fokker.
Thanks for coming. Curious to see what you have.
Jack Van Hengst, who was the chief engineer, had extensive aerodynamic studies and data on the effects of contamination on an F-28 airplane.
Fokker engineers have run simulations of the crash.
They were able to get some very good data in terms of the performance of the airplane, simulating the type of loads, temperatures, etc., that the Dryden aircraft would have been exposed to.
Investigators make a crucial discovery about the design of the F-28. Because of the angle of the wings, a very small amount of ice makes the plane susceptible to stalling.
They concluded that even the most minute bit of contamination on the wing would disrupt the airflow and cause a loss of lift.
Well, that answers a lot of questions.
The simulations support what witnesses saw.
It just barely got airborne, dropping wings, losing lift, and then hitting trees, decelerating to the point where it broke up.
Investigators are now certain that contaminated wings caused the crash. But what's still unclear is why the plane was not de-iced before takeoff. Almost all airports in cold climates, including Dryden, are equipped with the technology to remove ice from a plane. But Captain Morwood never requested de-icing.
It's getting worse. What's the latest?
Investigators need to figure out why. They want to understand what made him risk his own life.
Let's hope it holds.
And the lives of the 68 other people on board Flight 1363. Investigators dig through Captain George Morwood's flight records and work history. They interview crew members, searching for clues to his behavior.
Captain Morwood was a very professional, very old-school pilot. He had his view on how things should be done properly and what his definition of proper and professional would be.
He also was very concerned about his passengers. He enjoyed making sure that they got on their flights on time and got to their destinations on time.
You know, Air Ontario was a growing company. It was their first foray into the jet operations. I'm sure that there were many things that Captain Morwood would have thought in his own mind, this is not how he would do it. And I'm sure at times he probably let the superiors know that.
Morwood's history shows he's delayed and cancelled flights in the past because of icing concerns. Roa is stumped. Why didn't he request de-icing in Dryden? Another pilot who was at Dryden Airport that day provides part of the answer. He heard Morwood on the phone to Air Ontario.
That is what I have been trying to tell you.
He was very frustrated, and he was really concerned about his passengers.
Morwood complained to the off-duty pilot about the company.
These guys. You want to guess my weight before I left Thunder Bay? 66 and change. I had to offload fuel. Now that... Right. So now what am I supposed to do? No. You figure it out.
When he left the terminal, he was observed by witnesses to appear to be very upset and very angry.
Investigators wonder what set Morwood off. They try to piece together the pilot's day on March the 10th.
This was the 5th day of a very long week for Captain Morwood. And he was the next day leaving with his family on a ski vacation.
Before his first flight of the day, he'd learned the plane's APU still wasn't working. And then, once in Thunder Bay, more bad news. After refueling, the dispatcher forces Morwood to take on 10 extra passengers. Now he must offload fuel and lose more time.
There goes the schedule. Let's, offload some fuel then.
This meant Morwood would leave Thunder Bay behind schedule.
Dispatch, Ontario 363.
And Captain Morwood is the type of captain who didn't want to be late.
Now en route to Dryden, and an hour behind schedule, the weather forecast the crew was given of light rain and fog is no longer accurate.
And Captain Morwood didn't get the forecast of freezing rain coming into Dryden, which he should have had.
As Flight 1363 lands in Dryden, the weather was getting worse by the minute. The plane sat there for half an hour while snow built up on the wings.
I gotta talk to somebody about this.
Investigators may never know how concerned Morwood was about the weather. But there is evidence that it was on his mind. When Roa questions the fueling agent, he learns that Morwood did ask about de-icing moments before takeoff.
Is there de-icing available?
The fueling agent says he pointed out the de-icing ground crew to Morwood. The agent then offers a compelling reason that could explain why the captain didn't de-ice. Air Ontario had a policy prohibiting him from de-icing with an engine running.
The fluid can be ingested in the engines and then find its way from there to the air conditioning on the airplane and make it extremely noxious in the cabin portion of the airplane.
But if Morwood had shut down both engines, he wouldn't have been able to restart his plane.
Now, the only other way to start the airplane on the ground is with a ground-based air cart that can provide the compressed air. And Dryden did not have the capability to start the airplane.
The equipment would have had to be flown in from Winnipeg. It would have been a costly decision.
If he shut it down, he would ground the aircraft there effectively, requiring the billeting of passengers and hotels and at an expense to the airline for which he would be answerable.
Right. So now what?
So he was under a great deal of pressure.
No. You figure it out.
And I believe that the conversation on the phone would have been about that scenario and his displeasure with it. But he didn't have any other chance.
It's getting worse. What's the latest?
Quite heavy snow. Looks like it's going to be a bad one. It's still within our takeoff limits.
Well, that's good. We got a lot of people who want to make their connectors. Let's hope it holds.
Though the amount of snow on the wings was still within limits, It's what lay under the snow that doomed the flight. The fuel in a plane's wing can get as cold as -40 degrees Celsius. The frigid fuel cools the metal surface of the wing. When snow hits this supercooled surface, it freezes instantly into a barely visible layer of ice. It's a process called cold soaking.
And this, of course, is what's disrupting the airflow on the wing and destroying the lifting capabilities.
Tell them we're going immediately.
Kenora, Ontario, we're taxiing out at this time 360.
The only reason that I can possibly think of that led to his decision to execute the takeoff was the fact that he didn't consider the cold soaking phenomena and the fact that those wings could still have ice on them.
Advise Kenora, we're ready to proceed.
And Kenora, Dryden, Ontario.
Perhaps not wanting to face the consequences of shutting down his engines, Morwood opted to take off for Winnipeg without de-icing his plane.
He must have concluded that the ice would blow off on takeoff. That is where he made a mistake, a tragic mistake.
But Mashansky concludes that despite his mistake, Captain Morwood is not solely responsible for the crash.
It wasn't simply pilot error. There were myriad of factors which were the cause of the accident.
One of the most important factors, Air Ontario's decision to let the plane fly with a broken APU.
They were deferring a lot of the maintenance that should have been done because of a shortage of parts. And then they had to scrounge around all across Canada with various F-28 operators to borrow parts from them. And this was a very bad move on the part of Air Ontario management.
The investigation determines that by cutting corners and focusing too much on the bottom line, the airline was putting all their passengers and employees at risk.
Because the F-28s were new to Air Ontario, there was this urgency to get one crew off and get the next crew on flying. This urgency to have them in the air producing money.
I came to the conclusion after a lot of thought about this accident that there were a lot of other hands on those throttles, pushing those throttles forward. There were a lot of people that were involved in the sequence of events that led to this tragic outcome.
This was a preventable accident, but everything conspired against the pilots.
I gotta talk to somebody about this.
Because Air Ontario management did not have a safety culture. And you have to have a safety culture from the top management down.
Knowing there are dozens of Fokker F-28s flying around the world, Justice Mashansky takes an unusual step. He releases a report well before his inquiry concludes.
Good afternoon.
It warns of the plane's vulnerability to ice buildup and stresses the need for frequent de-icing in winter conditions.
Even a small amount of icing would be disastrous on an F-28.
But 15 months later, it becomes clear that Mashansky's warnings have not been heard. US Air Flight 405 is preparing to fly from New York to Cleveland on March the 22nd, 1992. The plane is a Fokker F-28, and it's snowing. It's 1 degree below freezing. At 9 p.m., the jet is being de-iced for a second time since its arrival from Florida. In the past hour, an inch of snow has fallen and shows no signs of stopping.
US Air 405, clear to taxi runway 13.
The crew prepares for takeoff. Flight 405 is an hour and 45 minutes behind schedule when Captain Wallace Majeur starts taxiing to runway 13. Then, unexpectedly,
US Air 405, turn left and hold short of Echo.
Left on the inner to hold short of Echo.
At 9:07 p.m., Flight 405 is forced to wait on the taxiway near runway 13. another 23 minutes pass. First Officer John Rashuba turns on a light that illuminates his wings. He checks the right wing for ice. He sees none.
Looks pretty good to me as far as I can see.
US Air 405, runway 13, clear for takeoff.
Even though it's now been 35 minutes since their last de-icing, the crew does not request another.
Takeoff thrusts set. Temps okay.
Everything proceeds as it should, until...
V1. Rotate.
Just after the F-28 begins its rotation.
The aircraft had enough flying speed to lift off, barely lift off. The wings just could not support the airplane. They knew they were in trouble.
13 seconds after lifting off, Flight 405 crashes on the shore of Flushing Bay.
I don't think any pilot really thinks he's going to crash. They were trying to save the airplane right to the end.
27 of the 51 people on board are killed. Another Fokker F-28 has crashed, with tragic consequences.
My reaction when I heard about it was, my God, it's Dryden all over again.
Within days, investigator in charge Robert Benson suspects that ice on the wings was the major cause.
It would be very, very difficult for either of the pilots to really detect ice on the wings, looking backwards over their shoulders through the side windows of the airplane.
Looks pretty good to me as far as I can see.
So the captain was faced with quite a problem. If he wanted to be de-iced a third time, he would have had to get out on the lines, taxi all the way back into the parking area, and meet up with a de-icing truck again.
Takeoff thrusts.
That would have put him very, very late, and it may have even caused the cancellation of the flight.
After all of this work, after all of the efforts, to see it happen again was extremely frustrating.
There were no regulations in place requiring the crew to seek another de-icing after their extended delay. But Justice Mashansky had called attention to the dangers of long wait times when he issued his interim report.
If they had followed the recommendations in my second interim report, this accident certainly could have been averted.
He also had drawn attention to the limitations of the de-icing fluid being used at the time. Called Type 1 fluid, it's a mixture of antifreeze and water.
Those chemicals are designed that as you accelerate down the runway, that they'll actually shed off your wing, so that when you actually want the wing to lift and produce lift, that it's not contaminated.
Type 1 fluid is applied hot to de-ice the plane's surfaces. But it doesn't last long.
Type 1 fluid had a holdover time in their best conditions of about 15 minutes. Under poor conditions, such as freezing rain, it could be as low as 6 minutes.
During the Air Ontario investigation, Mashansky's team reached a stark conclusion about the effectiveness of Type 1 fluid. Even if Captain Morwood could have de-iced his plane in Dryden,
We're fired up, taxiing for departure, requesting airways to Winnipeg.
it may have made no difference.
Hang on a sec, guys. Is there a chance that plane can hold? We're having some bad weather up here.
Unbelievable.
Flight 1363 had to wait for the troubled Cessna 150 to land.
By the time he waited for this 150 aircraft and pilot to land, and then they backtracked and got into position, now they're in a serious snowstorm, and they are getting contaminated.
Even if Morwood had de-iced during his 30 minutes on the ground,
Rotate.
the delay may have been enough for the fluid to stop working. The plane's wings may once again have become coated in ice.
It came out in the examination of Air Ontario pilots that there was a dire need for training in terms of how the de-icing, anti-icing systems worked and how long your aircraft was protected.
As soon as our accident occurred up in New York, we of course understood that it was a similar aircraft, in fact a nearly identical aircraft to the Dryden accident airplane. The circumstances were similar in both accidents, and the Dryden report was a tour de force, which helped us focus our investigation quite a bit.
Justice Moshansky had released his interim report more than a year before the crash of Flight 405. His recommendations could have prevented it. Moshansky would soon discover that a breakdown in communication had cost the lives of 27 people in New York. During his inquiry, Justice Moshansky learned that there was another type of de-icing fluid available to the airline industry. It's called Type 2 fluid. It's thicker than Type 1, which prevents it from immediately flowing off an aircraft.
A Type 2 fluid is a much more gooey substance. I've heard it referred to as almost mucus-like.
With holdover times of up to 45 minutes, it keeps ice from accumulating, then blows off the plane's surfaces at takeoff. 15 months before the US air crash, Moshansky recommended greater use of the thicker Type 2 fluid. Moshansky's investigators also studied de-icing practices at Toronto's Pearson Airport.
We got a hold of a film crew, and we waited and watched the weather very carefully until we found a forecast of freezing rain. And we tracked one aircraft which was heading for the Caribbean.
The investigators discovered an alarming gap in the time between de-icing and takeoff.
And from the time the aircraft was de-icing on the gate until the time the aircraft took off was somewhere in the order of 41 minutes. So there was no doubt that aircraft were departing Pearson Airport with a partially or largely contaminated wing surface. We then went to Chicago O'Hare. This was the first airport to actually put in place runway end de-icing pads. And it was very useful in terms of explaining to us how these had evolved, what type of de-icing equipment they were using on them, how they worked.
At the time of the US air crash, LaGuardia did not offer de-icing at the runway, only at the gate. Again, 15 months before the crash, Justice Moshansky recommended the placement of de-icing facilities at runways instead of terminal gates. Moshansky also recommended that pilots not only inspect their wings from the cockpit,
Looks pretty good to me as far as I can see.
but also from the cabin.
US Air 405, runway 13, cleared for takeoff.
Moshansky claims that his report could have prevented the crash at LaGuardia. But the Federal Aviation Administration claims it never received his report in 1990, and therefore couldn't pass the information along to airlines and pilots. But Justice Moshansky doesn't accept that.
My second interim report went out in December of 1990. It was about a year and a half before the LaGuardia crash occurred. So I think probably sat on somebody's desk.
The crash of Flight 1363 resulted in dozens of recommendations that could save lives. The crash of Flight 405 ensured those recommendations were widely implemented.
Well, there was a lot that came out of Dryden. I mean, the commission came out with 192 recommendations. It changed the whole nature of how we approach contamination.
We now have runway end de-icing pads, so they can get a final de-icing before they take off. This was something directly the result of the Dryden Commission inquiry.
Today, most airlines use a new type of de-icing fluid. Type 4 de-icing fluid lasts longer. It will stick to a wing for up to 2 hours. As well, air traffic controllers must now be able to tell flight crews how long they will be delayed at the runway after being de-iced.
Dryden is really the first accident that explored not only what happens in the pointed end of an airplane, but what happens within a corporate culture. It put CEOs on notice that they can't hide in the woodwork when an accident occurs.
Dutch manufacturer Fokker went bankrupt in 1996. Despite this, in 2009 there were still 55 Fokker F-28 jets in operation worldwide, mostly in warmer climates.
Nobody should ever lose their life due to a contamination accident again in commercial aviation, anywhere in a snow and ice environment. We've learned all the lessons.
Just minutes from Strasbourg Airport, an Airbus A320 slams into a mountaintop.
Delta Alpha, your position?
There are survivors.
I'm not panic because I'm going to burn.
But they are still in grave danger. It's bitterly cold, and what they don't realize is that no one knows where they are.
They could be anywhere in there.
Expect this in the jungle or the rainforest, but not in a highly populated area.
Before investigators can begin searching for what caused the crash of Air Inter Flight 148, they must first find the plane. January the 20th, 1992. Air Inter Flight 148 has departed from Lyon, France.
124.905, thank you.
Captain Christian Hequet and First Officer Joël Charubin are experienced pilots with over 12,000 hours of flying time between them. The flight is a short hop between Lyon in central France and the city of Strasbourg in the mountainous Alsace region. The French airline Air Inter caters mostly to business travelers and prides itself on being timely. Crews are motivated to avoid delays, as former Air Inter pilot Gérard Arnoux explains.
We were famous for a very short turnaround. And the faster we flew, the better wages we got.
Have we been flying for 35 minutes yet?
41 minutes.
The crew is flying an Airbus A320, one of the most technologically advanced commercial airplanes in the world. Even before takeoff, the pilots programmed the autopilot to land on a specific runway in Strasbourg. The cockpit of the A320 is also very different from other planes. Instead of analog gauges, the pilots look mostly at digital displays.
Strasbourg, good evening. Runway News 05. Transition level 50. Wind 040 at 18 knots. Visibility 10 kilometers.
A recording from Strasbourg Airport informs the crew of a change in plan. Due to high winds and poor winter weather, they'll have to land on an alternate runway.
05 in service.
Not the one programmed into the autopilot.
05. What sort of wind are they giving us?
18 knots.
18 knots.
Captain Hequet doesn't like the idea of changing runways.
No chance.
He was hoping to use runway 23, an approach that provides the autopilot with a precise navigational fix. The new runway, runway 05, is surrounded by mountainous terrain that can interrupt radio signals sent to the autopilot.
You know, if we go with the runway 05 procedure, we... Oh, no.
Captain Hake suggests a compromise.
I'm putting back runway 23. Otherwise, I couldn't make the ILS interception.
He'll program the autopilot to fly towards runway 23. But near the airport, the captain will take over the controls and make a visual landing on runway 05.
You're taking 23 then?
Yes!
Ladies and gentlemen, we are commencing our descent. We ask you to please return to your seats.
Nicholas Skourias is a university graduate student.
It was a quiet day. I was expecting to go to see my girlfriend in Strasbourg, so I was very happy.
Roger 854, proceed to GTQ air level 140, contact Reims. Delta Alpha, Strasbourg.
Yes, we intend to proceed to do an ILS on runway 23, then an indirect for runway 05 after that.
The Strasbourg controller considers the captain's plan. He warns that there will likely be a delay due to heavy traffic.
Given that we're going to have 3 takeoffs on 05, you risk waiting in a stack at 5,000 feet.
We're not going to mess about like that, descending at full speed. If they had warned us in advance, cripes!
Delta Alpha, Strasbourg.
I hear you.
Aware of the captain's frustration, the controller offers assistance.
If you want, I can take you with the radar to lead you to Andlo at 5,000.
Andlo is a navigational point on the approach to runway 05. It helps pilots align the plane for landing.
Yeah, that's good.
Oh, yeah. Okay, then, turn left to heading 230 degrees. 148.
Turn left to heading 230 degrees.
There you are. That will save you some time.
Since runway 05 doesn't allow for a full autopilot approach, the captain must calculate the angle of descent on his own.
That makes 3.3 degrees.
Donc 3,3, c'est tout à fait normal, oui.
3.3 degrees is a normal flight angle that provides a good slope for landing.
Doucement, la bonne pente, voilà.
Ladies and gentlemen, we are continuing our descent.
The flight from Lyon to Strasbourg was quite short. I think 50 or 45 minutes. Nothing special. It was very natural and very ordinary.
Thank you.
Turn left, steer 90. 090 degrees, Delta Alpha.
The controller talks Flight 148 through the last turn to align the plane with the runway, now 25 kilometers away. Then, First Officer Cherubin notices the plane is slightly off course.
We're headed inside. You're inside there. You should have started with 070.
Yeah.
At least that much.
The controller also notices that the plane is off course.
Air Inter, Delta Alpha.
It has missed aligning itself with Andlo, the runway's electronic guidepost.
Delta Alpha, you're passing to the right of Andlo.
Nevertheless, he authorizes the landing.
Authorized for final approach 05.
Delta Alpha.
The captain initiates the landing sequence.
Flaps towards 2.
Flaps towards 2. Flaps at 2.
Gear down.
Ladies and gentlemen, we are going to land in a few minutes.
Heke notices that the plane is traveling too fast, so he extends the speed brakes. They disrupt airflow over the wing, which helps create more drag to slow the plane.
We have to watch our descent.
The approach axis.
The first officer is more concerned with their horizontal position in relation to the runway.
It was 60. Check it out.
Right.
But before the crew can adjust their course,
Delta Alpha, your position? Air Inter, Delta Alpha, Strasbourg.
the crash is catastrophic. The A320 has flown into the side of a mountain.
Delta Alpha, your position?
Flight 148 is no longer on radar, nor responding to radio contact. An emergency is declared at Strasbourg Airport.
This is the last hit we got. We were flying about 20 kilometers away from the airport.
Officials need to pinpoint the crash site, but it's not as easy as it might seem. The airport's radar is not recorded. There has been no signal from the plane's emergency beacon, and surprisingly, no one has reported seeing a plane go down.
It could be anywhere in here.
The proposed search area covers more than 20 square kilometers of dense forest just outside Strasbourg. Nicolas Scoria survives the crash of Air Inter Flight 148 with only minor injuries.
I took off my seatbelt, I get up, I tried to find my suitcase in the lockers, but there wasn't any lockers. I realized that I was alive. It was a crash. I saw a fire in front of me, and I panicked because I said to myself, I'm going to burn. I went to the back of the plane, of what remained of the plane. I found some other survivors.
Come on! It's gonna blow!
I was afraid of the explosion. I was panic.
With the smell of leaking jet fuel in the air, the survivors move away from the burning plane.
We stayed together, waiting for the first aid.
But the wait will be longer than anyone might expect.
The first reaction that we have after the crash was, okay, in half an hour, 1 hour, most, and the worst, okay, the rescue team will be here. And it wasn't here.
1 hour after the crash, rescuers still have no idea where the wreckage lies. Skouries and the others now face a new ordeal. Surviving sub-zero temperatures in a dark and isolated forest. 2.5 hours after Flight 148 disappeared from radar near Strasbourg Airport, the missing plane has still not been located. Amidst growing tension, the French Aviation Bureau, the BEA, sends in its lead investigator, Jean Paries.
I immediately called my two main investigators, and we organized the GO team, and we got prepared to rush to the site as soon as this site was located somewhere.
The delay feels like an eternity.
A little bit surprisingly long. We can expect this in the jungle or the rainforest, but not exactly in a highly dense populated area like the Strasbourg area.
With no help in sight, Skouras returns to the wreckage to look for more survivors.
I think that some people that die could have survived if the first aid come sooner.
Nearly 1,000 people search for the missing plane. But 3 hours after the crash, there's still no sign of it. Frustrated, Skouras goes looking for help. He stumbles into a TV crew trying to find the crash. But with no wreckage in sight, they react with skepticism.
They didn't expect survivors from an airplane crash.
Hey, you have to believe me!
They didn't believe that I was one of the survivors, but believe me, I was, because my face was black due to the smoke, the kerosene, and so on.
Come on!
The journalists follow him back to the crash site, where they discover 8 other survivors. Finally, the first rescuers arrive. The crash site is located near the top of the 2,500-foot Mont Saint-Odile, 19 kilometers from the runway.
They found us after 4 hours and 30 minutes. So it was a mess. I was very, very disappointed that at 20 kilometers from Strasbourg, and they couldn't find us.
A total of 87 passengers and crew have died, including the pilot and co-pilot. The survivors begin to tell their stories, but no one reports anything that might explain why the plane crashed.
I don't know what happened. We were landing. I lost all consciousness. We must have hit the trees.
Bob McIntosh, an American NTSB investigator, arrives at the crash site.
The BEA of France recognized the international attention would be on this accident, even though it was a domestic accident. He invited a group of international accident investigators to come and participate.
Welcome to the team.
The first priority for investigators is to retrieve the plane's black boxes.
We have not removed the recorders yet. Good.
With the boxes trapped in the burning tail section, any delay could prove costly.
We're very anxious about the state of the tape inside. Will it be possible to use it? Will we get the critical information we need?
In France, aviation accidents are also investigated by the justice system. Parias and his team are not allowed access to the site until judicial officials secure the black boxes.
I had a visual picture of the gendarme, Aryan, transport police standing around keeping us away from the wreckage for a while. And we're very suspicious of these international observers.
Maybe we should wait.
Even taking photographs, which was somewhat surprising to us.
In a previous crash, the crash of Air France Flight 296 in 1988, investigators waited 10 days before turning the black boxes over to police. Rumors persisted that these boxes had been tampered with. This time, police are keeping investigators at bay.
I can recall seeing the glowing embers and seeing the flight recorder sitting there and not being able to intervene and say, get that thing cooled down as soon as you can.
After midnight, the boxes are retrieved from the plane and sent for analysis. Investigators can only hope it's not too late.
They was extremely hot. They looked damaged. They looked burned.
On découvre l'Airbus disloqué à 500 mètres.
In the light of day, investigators get some of their first clues from the crash site itself. They discover why the plane's emergency locator beacon didn't send a signal.
It was actually destroyed by the impact.
The beacon is located inside the cockpit and is designed to start working after a crash. Its failure suggests an unusually forceful impact with the ground.
We had this first feeling that the descent was abnormally steep.
Investigators examined the engines to see if they may have stalled before impact.
If you find the blades curved and a lot of wood sucked inside the engines, then you understand that the engines were working properly.
And that's exactly what they find. The plane clearly had power, yet it plowed steeply into a mountainside without ever sending out a distress signal. Investigators are puzzled. They hope that the box which recorded the plane's flight data will help them solve the mystery.
Those particular recorders had the best survival record of any recorders. They were the top of the line as far as survivability is concerned.
The black box is designed to survive temperatures up to 1100 degrees Celsius for half an hour. The tape recorder inside is protected by a capsule filled with water.
When the recorder heats up, the water turns to steam, absorbing the energy, and actually vents out through a little hole in the crash enclosure.
But when the flight data recorder is opened, investigators make a troubling discovery.
DFDR was totally damaged. Impossible to read anything from it.
It was subjected to heat beyond the 30 minutes. The recorder was just never designed to withstand that kind of sustained heat.
And so we were very disappointed.
There's now only one hope for recovering the plane's flight data, a device called a quick access recorder, or QAR. Maintenance workers use the QAR to access the plane's computers, but it also records some flight data. Unlike the black boxes, the QAR is stored near the cockpit.
Quick access recorders are not protected at all. They're up in the front end of the aircraft, typically in the electronics bay. They're generally destroyed just from the impact damage.
Investigators are encouraged to discover that in this case, the QAR has survived. But on closer examination, their optimism turns to frustration.
The last 20 centimeters of the tape were burned and stretched and were damaged to the point that we could not use them into a machine. We couldn't read it.
Investigators are desperate to retrieve the data, so they take a chance on an experimental technique. Known as the garnet technique, a light is shone through a mineral lens made of garnet.
Use a garnet stone to visualize the magnetic pulses that are actually recorded on the tape.
The special lens helps the technicians differentiate between the positive and negative magnetic pulses, which translate as binary digits, or bits.
There's 768 bits per second, so that's a lot of ones and zeros. You have to be very precise in moving the tape under the lens or the garnet to make sure you don't miss a bit or read the same bit twice, you know? So it's difficult.
Analyzing the data is even more painstaking.
It took about a day to read a second of recording. Any additional second recovered could reveal something that would make a difference.
The effort to retrieve all the QAR data could take a month or more. In the meantime, the focus of the investigation shifts to the cockpit voice recorder. It was positioned just above the other black box.
The cockpit voice recorder, which was just inches away, but outside of the ashes, had air passing over it, survived.
Runway 23. Otherwise...
The recording reveals the captain's anxiety early on in the flight.
You're taking 23 then?
Yes!
Investigators know that landing on runway 05 requires what's called a non-precision approach. That means pilots receive electronic guidance only on their horizontal position, left and right. They get no guidance when it comes to altitude.
The non-precision approach is significantly less accurate. Why, it's not really difficult, but they are less comfortable.
05. What sort of wind are they giving us?
The non-precision approach increases the demands on the pilots. Investigators can also hear that the captain had concerns about landing on runway 05.
48 Delta Alpha, you are number 1 with VOR DME runway 05.
Runway 05.
10 nautical. That won't work.
It's a lot of distress over a non-precision approach.
Wondering what can cause such distress, investigators research pilot training at Air Inter. They find that most pilots did not have extensive training making non-precision landings in the new A320.
I think we should have had double the training compared to an older plane.
Investigators ask the airline for detailed records on the pilot's history of runway approaches. They're intrigued by what they discover. Captain Heke had landed at Strasbourg countless times, but he had never landed an A320 there using a non-precision approach.
We're not going to mess around like that descending at full speed.
Clearly, the captain was uneasy about having to execute a landing he had never made before.
I think the captain was worried about making it in a minimum amount of time, in the minimum amount of delay.
Have we been flying for 35 minutes yet?
And the co-pilot was worried about not getting in trouble by offending the captain.
At least that much.
More research into the pilot's work history offers yet another revelation. While the two pilots had flown more than 12,000 hours between them, they were both still relatively new to the highly advanced A320.
It's 05 in service.
The aviation community misunderstood the magnitude of changes brought by the new Airbus A320.
The captain had only 162 hours in the A320, and the co-pilot even less, just 61 hours.
Behind this accident scenario, there's an issue of confidence of the crew in themselves, in the aircraft.
18 knots. No chance.
They were not prepared, really, to fly in this kind of condition.
If they had warned us in advance, cripes!
Investigators conclude that the crew's training was insufficient. But that alone does not explain the crash.
Merde!
Investigators search for other factors in the crash of Flight 148. They review the conversations between the crew and air traffic controllers.
If you want, I can give you radar headings and take you to Anlo at 5,000.
Yeah, that's good.
The radar vector makes flying easier. The captain was happy because it was reducing his workload.
Turn left, steer 90.
With the controller's assistance, this landing should have been very simple. But when investigators reconstruct the plane's trajectory using radar information from various stations around the airport, they discover a shocking error.
The 090 heading started here.
09er, 0 degrees, Delta Alpha.
But it won't take them to Andlo. Last radar vector the controller gave was incorrect. It sent them...
Thank you.
...closer to the mountain.
They were, of course, because of following the heading they got from the radar vectoring, they found themselves in this undershoot situation.
You're inside there. You should have started with 070.
Yeah.
Investigators are also troubled by the controller's choice of words when he warned the pilots, incorrectly, that they were headed to the right.
Delta Alpha, you're passing to the right of Anlo.
From the pilot's perspective, the plane was on the left side of the runway, not the right. It could only add to their confusion.
Le contrôleur, en fait, il a fait un...
It was very poor guidance because he didn't employ the usual terminology.
Et il n'a pas utilisé la phraséologie standard.
Investigators recommend that controllers use only compass points when giving directions. Never the words right and left. The controller's mistakes clearly brought the plane closer to the mountain.
Turn left, steer 90.
090.
But once again, investigators feel they don't have the whole story.
It's not something totally abnormal to start a descent from this situation.
Flaps towards 2.
Flaps towards 2.
It's not what you expected to do every day, but it's not outside the tolerance of the concept of this approach.
Gear down.
When investigators study the plane's reconstructed flight path, they discover something more alarming than the plane's horizontal misdirection. As it circled the mountain, the plane inexplicably entered a dangerously steep and rapid descent.
Perhaps 2.5 times the normal rate of descent.
That's lethal at that altitude.
Without the steep descent, they would have cleared the mountain.
If the vertical trajectory had been correct, they would have no problem at all.
Finding the cause of that sudden descent is now key to understanding why 87 people died in one of the most advanced passenger planes on Earth.
Authorized for final approach 05.
The descent was initiated at 1800 hours, 19 minutes and 38 seconds. That
Delta Alpha.
is the point of no return.
By studying Flight 148's trajectory, investigators determined that the rapid descent began 60 seconds before the crash.
Delta Alpha.
There is no indication on tape that the descent was deliberate. How it happened and why the crew didn't notice is a mystery.
It should be a no-brainer. Keep track of the altitude.
The cockpit altimeter gives pilots a constant readout of their altitude.
Altimeter, that's a very precise instrument. They become very reliable. They're accurate to within 5 or 10 feet.
Ignoring it would be a major error in flying protocol.
Flaps towards 2.
The recording reveals just one single remark from the crew about their descent.
We have to watch our descent.
It occurred 16 seconds before the crash. The captain had just extended the speed brakes.
The aircraft was accelerating abnormally. The captain started to realize there was something wrong with the descent rate.
But the first officer changed the subject.
The approach axis. We're hitting the axis a half point off.
There. It was 60. Check it out.
He refocused the captain's attention on the lateral situation rather than the vertical situation, which was the main problem, of course. And they both failed to recognize this situation.
I think they were planning that we're going to break out of the clouds so they'd be able to see the runway, and they wouldn't need to do the full instrument approach.
It was 60. Check it.
But the plane never left the clouds.
There's an old adage in aviation. Rocks have been known to hide out in those clouds.
It now seems clear that the crew was not monitoring their altitude closely enough. But a bigger mystery remains.
We can only guess why.
What caused that deadly descent? After months of work, investigators may finally have the answer. All the available flight data from the damaged quick-access recorder has been recovered.
We were very anxious to be able to read as much as we could.
The data confirms that just before the crash, the plane was speeding towards the ground at an extremely high rate. 3,300 feet per minute. It also confirms that the angle of descent was dangerously steep, much greater than the 3.3 degrees selected by the captain.
3 degrees.
That's quite a difference.
Investigators now wonder, did the autopilot malfunction? Did it somehow fail to obey the captain's safe descent angle and send the plane into a deadly nosedive?
But what state was it in before the accident?
Unfortunately, the flight control unit which houses the autopilot is too badly damaged to provide any definitive answers.
We could never demonstrate that this FCU on this aircraft during this flight functioned properly or not.
But then, when he returns to studying the flight data, Paris discovers something that may finally reveal the cause of the crash. He notices a similarity between two key numbers: the plane's vertical speed, 3,300 feet per minute, and the intended flight path angle, 3.3 degrees.
Coincidence?
Paris uses a flight simulator to test a new theory.
Can you show me a descent of 3,300 feet per minute?
He believes that the similarity is no mere coincidence. On the autopilot, there are two descent modes: flight path angle and vertical speed. But they are both displayed on the same window. So 3,300 is abbreviated to 33.
Now, show me a flight angle of minus 3.3 degrees.
The problem on this aircraft was that the two values were visible on the same window and controlled by the same knob.
3.3 degrees.
Minus 3.3 degrees.
Paris strongly suspects that the confusing display tripped up Captain Heke.
So it wouldn't be hard to make that mistake, would it?
The confusion is quite easy between the two modes if you don't do it carefully.
If the captain failed to push the mode selector knob, then entering 33 would not have initiated a safe 3.3 degree angle of descent. Instead, it would have put the plane into a deadly rate of descent of 3,300 feet per minute. Two months after the crash, another Air Inter plane enters a dangerously steep descent for the same reason.
The crew only discovered the problem when they broke out of the clouds.
Those pilots also confused the plane's flight path angle with its vertical speed.
They were lucky enough to have a much higher cloud base so they could correct the problem.
Further research reveals an industry-wide problem with the A320.
Many people confuse these modes, especially during training, and many of them fell in the trap even after the training.
Eager to test his new theory, Jean Paris programs a simulator with all the known data from Flight 148.
Okay.
He then inputs the same rate of descent he believes the Air Inter pilots selected. If Paris is correct, the simulation will end with the plane hitting the mountain. But it doesn't.
We're missing something.
Strangely, this didn't lead to a crash. Every approach would overfly this obstacle by a significant margin.
Have we factored in the wind?
We started to work on other alternate hypotheses.
Let's try again, but initiate the turn sooner.
But nothing was really credible.
No matter how hard he tries, Paris cannot simulate the crash. Unable to explain why, he turns to the plane's manufacturer for help.
Thanks for bringing this to my
After
attention.
much research, an Airbus designer comes to Paris with an explanation about a little-known element of the autopilot's design. In emergency situations where the A320 needs to change direction quickly, the autopilot is programmed to reverse the plane's direction at twice the normal rate.
the reaction of the autopilot would be much faster. And these cases were typically when you were descending and asking the autopilot to climb, or climbing and asking the autopilot to descend. We immediately went back to the data at the very second at which the descent was commanded by the crew.
Gear down.
Paris discovers a tragic coincidence.
Sadly, we found that at this very second, there was turbulence.
There was an ascent. It's very slight, but there it is.
The momentary turbulence caused the plane to climb slightly.
And this led to a positive 600 feet per minute vertical speed for maybe half a second.
It was during that same half second that the crew commanded the plane to descend.
It was 60, check it out.
The autopilot read this as an emergency requiring a blazingly fast descent.
That could be it.
Investigators now contemplate a terrible thought. Could a random gust of wind, hitting at exactly the wrong split second, have been the difference between life and death?
Here it comes.
And we got a crash.
Paris's theory explains every aspect of the crash. The crew's confusion with the autopilot display
3.3 degrees
caused the plane to descend dangerously close to the mountain. Turbulence and an obscure safety feature brought it even closer. It was a fatal combination.
It's a fascinating lesson about the random dimension of accidents. Half a second before, half a second later, they wouldn't have the accident.
The discovery of a confusing cockpit display has enormous implications for the entire industry.
The flight instrumentation of aircraft like the DC-10, MD-11s, the 747s, and so on, all the Boeing products and all the commuter products that were using that avionics suite had this vulnerability about it.
Investigators now face a daunting question affecting aircraft safety around the world. If the design of the autopilot interface isn't changed, how many more people could die? There's mounting evidence that the design of the autopilot interface on Airbus A320s led the Air Inter pilots to accidentally dial in a dangerous rate of descent.
3.3 degrees.
We felt a need to start the industry to work on this.
The plane's manufacturer, Airbus, responds immediately.
The main change, which was very quickly made, was to change the display window.
With the new design, if a pilot selects a vertical speed of 3,300, the entire 4-digit number is displayed.
So the confusion between an angle and a vertical speed was no longer possible.
For investigators, only one mystery remains. All Airbus A320 jets are designed to be equipped with a safety device known as a Ground Proximity Warning System, or GPWS.
Which is a downward-looking single-purpose radar that tells you how high you are above the ground directly beneath the airplane. And if it gets to be too low, it'll set off a warning.
Pull up, terrain. Pull up.
But Captain Hake
We have to watch our descent.
never received a warning for one very simple reason. His A320 didn't have that alarm.
The first question, of course, was why the aircraft was not equipped.
So it's not part of the minimum equipment list.
The Air Inter management had decided they did not like the false warnings that had been produced by GPWS equipment.
Normalement,
Normally, most planes fly slower than 250 knots when under 10,000 feet, but we flew at 350 knots until the final approach. So at those speeds, GPWS was always giving off false alarms.
Dans ces conditions, parce que il générait des fausses alarmes.
This decision, while legal, prevented the pilots from having one last line of defense before crashing into the mountain.
C'est pas possible d'imaginer un instant.
It's impossible to imagine that the pilot wouldn't have pulled up if he'd heard the alarm.
We should have a GPWS on commercial flights in any case, yes. That's an obvious conclusion.
The report lists these causes: flight deck aerodynamics.
Investigators conclude that there was no single cause for the crash of Flight 148.
Training, lack of GPWS.
The tragedy involved an ill-fated combination of many different weaknesses in the airline industry.
We made 35 or so recommendations, including pilot training, about the ground proximity warning system, and so on.
The recommendations lead to sweeping changes. Pilots must now have more A320 training before getting behind the controls.
One of the two pilots now need to have at least 300 hours on the plane. They estimated that 300 hours were enough.
Another change, the design of a more heat-resistant black box.
The FAA did a test, did some studies what the thermal characteristics of post-crash fires were, came up with a value of 260 degrees C for 10 hours.
Delta Alpha, your position? Air Inter, Delta Alpha, Strasbourg.
As a result of the Strasbourg crash, the A320 is now a safer plane.
You can only get this change if there is what people perceive to be a good reason. And sadly, a good reason is still an accident.
But improved aviation technology is still no substitute for well-trained, well-prepared pilots.
There's an old axiom in aviation that you taught early on, that never let an airplane take you somewhere that your brain hasn't visited at least 5 minutes ahead of time. This is an excellent example of a flight crew that didn't follow that particular axiom.
Miami Beach, Florida. Sun, sand, and calm blue seas. But when a tourist points his camera towards the sky, he captures a scene of horror. A plane is falling to the sea.
We have a code 4. Repeat, code 4. A plane down in the water.
As soon as I saw this, I realized, I'm like, oh no, this is the Chalk's airplane crashing.
The downed plane is Chalk's Ocean Airways Flight 101, bound for the Bahamas.
Could it have been a collision with an object? Could it have been a fire? Could it have actually been a criminal act? Let's notify the FBI.
The incredibly rare video may hold the answers.
Can you enhance that for me?
An airline renowned for safety has made a fatal error. But it will take investigators hundreds of hours to finally uncover it.
Bingo.
The Port of Miami, December the 19th, 2005. Giant freighters and ocean-going cruise ships are a common sight. But there's another, much smaller craft that's often seen in this port. Chalk's Ocean Airways flies seaplanes in and out of this busy waterway. Today, Flight 101 from Fort Lauderdale is making a brief stopover here on its way to the Bahamas.
Feather propellers.
Check.
Shut down engine number 1.
Shutting down engine number 1.
Chalks flies to 2 regular destinations, both in the Bahamas. Bimini, where Flight 101 is scheduled to land this afternoon, and Paradise Island.
Ladies and gentlemen, this is your captain speaking.
We're just making a short stopover here in Miami to pick up a couple passengers. We apologize for the delay. We'll be on our way again soon.
How many are we picking up?
Just 2, but they're VIPs.
For a small community like Bimini, Chalk seaplanes are a lifeline.
And it's just so much easier in the seaplane to get to the North Island where most of the population is than going to the airport down there. So that was the main thing. It was a convenience factor.
Welcome aboard. Let's see your boarding passes.
Certainly.
Sergio Danguillacourt is a Bacardi rum executive. He's the great-great-grandson of the company's founder. The family is well known in the local Cuban community for their anti-Castro politics. He and his wife are flying to the Bahamas to buy a yacht.
Passengers settled in?
We're all set.
Good afternoon, folks.
We'd like to welcome you aboard Chalks Ocean Airways Flight 101 to Bimini. Our travel time to Bimini will be 25 minutes.
Hope you enjoy the flight. Let's have the startup checklist, please.
Roger.
Michelle Marks is in command of today's flight. She was promoted to captain earlier this year. First Officer Paul DeSanctis joined the airline 8 months ago.
Starter on.
Starter on.
This is his first flight with Captain Marks.
All clear to taxi?
All clear.
The Grumman Mallard is a twin turboprop design. It has a V-shaped hull and underwing pontoons. It's designed to carry up to 17 passengers. The plane has retractable landing gear, so it can operate on either land or sea.
Gear coming up.
Takeoff in the Mallard, depending on the days, it could be a lot of fun or it could be a real challenge.
Weight and balance check. We're good.
The Miami seaplane base has no control tower. The crew has to keep a lookout for boat traffic as they taxi through one of the busiest ports in the world.
Taking off out of Miami in the shipping channel, it's kind of like trying to take off during rush hour traffic. You've got boat traffic, wave traffic, the wind, the airplane to deal with, and everybody's going different speeds, and you're trying to get up and go and navigate around everybody, so it was always a handful.
Flight 101 will take off from X-44, a seaplane base near a channel known as Government Cut.
Prepare for takeoff.
Roger. Ready to take off.
Both pilots have their hand on the throttles. It's to prevent the captain from inadvertently pulling back if the plane hits a wave.
45 knots. 50 knots.
This is the moment most passengers are paying for, the takeoff. Half speedboat, half plane. It's a unique thrill.
75 knots. 80 knots.
For the pilots, accelerating through the waves is often the most difficult part of the flight.
The airplane itself was really hard to fly as far as on the water, getting onto the step, which was what we call getting on plane. And in rough sea conditions and in rough wave conditions, it could be a real challenge.
But this takeoff goes smoothly. Flight 101 is no longer a boat, it's now a plane en route to Bimini. It's 2:38 in the afternoon. The plane's flight path takes it past South Beach, where sunbathers and surfers are out in force. Just less than a minute into the flight, the Grumman Mallard is climbing through 500 feet, well below the clouds. Then, the plane rolls violently and dives. The pilots barely have time to register what's happening. Their struggles are in vain. By chance, a tourist from New York catches Flight 101's final moments on his camera. 60 seconds after takeoff, the plane slams into the ocean. Lucas Bocanegra is a lifeguard stationed on South Beach near the Chalks Ocean Airways sea lane.
As soon as I saw this, I realized, I'm like, oh no, this is the Chalks airplane crashing.
We have a code 4. Repeat, code 4. A plane down in the water.
This is Lucas. We're launching the jet ski.
The two lifeguards are the first rescuers to go looking for the plane.
We drove as fast as we could to the scene of the accident. There was a lot of things coming through my head. I was nervous, scared. I was kind of full of adrenaline. We wanted to go in and try to rescue as many people as we could, but at the same time, we've never trained for a situation like this. As soon as we turned government cut, those jetty rocks, we noticed that it was very calm, very quiet. It wasn't like the ocean side where it was very rough. There was no waves. It was very, kind of very eerie.
At first, Lucas Bocanegra finds no sign of Flight 101 or any of the passengers.
Little by little, we started seeing debris float up onto the surface of the water. And we saw some chairs, some luggage here and there, and suddenly we noticed it was a body in the water. As soon as we put the body on our jet ski, we realized that from his injuries that there was nothing we could do. From there, it was just try to recover as many bodies, you know, bring them back for their families.
News crews swarm the beach.
Chalks Flight 101 plummeted into the channel in full view of tourists lining Miami Beach.
Even a fraction of a second, the whole plane was engulfed in flames.
Black smoke and then an explosion. Pure fire in the sky.
It was so surreal, we couldn't believe that we actually witnessed that.
Chopper 4 over the wreckage as Miami Beach Coast Guard look for any survivors.
But the effort is futile.
We retrieved some of the bodies, but we were unable to find anyone that had survived.
All 20 people on board are dead, including pilots Paul De Sanctis and Michelle Marks. The residents of Bimini are devastated by the horrific news.
I was very sad for the crew and the friends that I had lost on the airplane. You never expect an accident to actually happen. And to see that on television like I did, it was very, very sad.
In Washington, senior NTSB investigator Bill English is put on the case.
I was just in my office doing some routine paperwork for something else, and the director stuck his head around the corner and said, "Oh, there's been an accident." And I said, "Well, what is it?" And he mentioned a Grumman Mallard. So I immediately knew it had to be Chalks.
Within hours, investigators are at the crash site, where 19 bodies have been recovered. One is still missing.
I was very familiar with Chalk's Airways. I'm a seaplane-rated pilot myself, and there is the reputation, the legend of Chalk's Airways, the oldest continuously operating airline.
Chalk's has a long and rich history. The airline was founded in 1917. During the Prohibition era, passenger lists included notorious rum runners and later Hollywood movie stars. Chalk's planes even patrolled for German U-boats during World War II.
The novelty of flying at Chalk's, it was just all that history, all the people that have gone, and it was really a great place to work for that.
The Grumman Mallard flying boat that crashed was built in 1947. Chalk's Ocean Airways is the only airline that uses mallards to transport passengers.
They're not really a mainstream type of airplane, and so there's always that nostalgia about them.
Salvage crews find the plane's black box. Investigators send it to the NTSB in Washington. The box promises to reveal critical information about what the pilots were doing in the seconds leading up to the tragic mid-air disaster.
In any investigation, the flight data recorder and the cockpit voice recorder are a great desire. More data, the better. We can always learn something.
But Bill English knows he isn't going to get all the data he wants.
Okay, thanks.
The only recorder on board the Mallard was a cockpit voice recorder, or CVR.
Most airline aircraft have two flight recorders. The flight data recorder, depending on the aircraft, will record all sorts of parameters of the flight: altitude, airspeed, control positions, and so on. The Chalk's airplane was not equipped with a flight data recorder. It did have a cockpit voice recorder.
Though the lack of flight data is a big disappointment, media coverage of the crash gives investigators a very rare piece of evidence.
Authorities revealed that the final seconds of Flight 101 were captured on amateur video. The dramatic footage was shot by a tourist on South Beach.
Let's get a copy of that video. Okay, let's see it.
The video only captured the final seconds of the plane crash, but it confirms eyewitness reports that a wing ripped off in midair.
Can you enhance that for me?
The video showed the wing just after separation from the aircraft, the main part of the aircraft fuselage rolling off in the other direction, and the fire and smoke starting from that.
It was quite startling that the wing would fall off in this plane. It was a beautiful day. The water wasn't rough on the takeoff, and all of a sudden this wing just dropped off. It must have been absolutely devastating.
However, the video can't reveal why the wing came off. Answers to that question may lie at the crash site, where salvage crews are finishing their recovery of the wreckage of Flight 101. The right wing is found separate from the plane, but largely intact.
Wings falling off aircraft, modern day situations, is a very rare, extreme event, and there's only been a few cases of them in the past 20 or 30 years.
In Washington, another type of examination is already underway. At the NTSB lab, technicians are busy analyzing the Mallard's cockpit voice recorder tape.
The cockpit voice recorder, CVR, which does what it sounds like, records the pilots' voices talking to each other or on the microphones.
But the tape is a jumble of voices and sounds. technicians can't retrieve any useful information.
It turned out that the erase head function, it's just like a tape recorder that most people are familiar with. It didn't erase the old stuff, so every subsequent flight kept getting recorded over and over and over again and just became a muddled sound, and it wasn't audible to us or useful.
It's another setback.
124.5, United 2166, thanks.
Okay, let's revisit this again because we're running out of options here.
Investigators have fewer and fewer tools to work with. Bill English considers the possibility that Flight 101 hit turbulence so violent that it tore the plane apart. But the weather on the day of the crash doesn't support that theory. There were no storms that could have caused such severe turbulence. Clearly, something else had torn this plane apart. There's a possibility the Mallard collided with something in the water before takeoff.
Seaplanes don't take off of a conventional runway. They're in water where there can be things like logs or other debris, which could potentially cause structural issues with an aircraft.
But before they can reach a conclusion on that theory, investigators consider some other intriguing evidence. It's an urgent advisory issued by the Federal Aviation Administration, or FAA. It warns that due to a faulty part, the propellers on the Mallard could come off during flight.
You're kidding me.
Something such as a blade separation, losing part of the propeller, could cause a great structural load on the aircraft.
English now has a solid lead, but his team is still missing the evidence they need to prove their case.
The entire island is devastated by the loss of life as investigators searching for answers wait for more wreckage to be pulled from the sea.
In the aftermath of the crash, Chalk's Ocean Airways grounds its remaining fleet of 4 Grumman Mallards. At the NTSB's Miami command post, they're working to identify various plane fragments and other debris from the crash.
We started out with the wing itself that separated the spar, which is the main part of the structure of the wing, and any of the other fracture surfaces, looking for obvious initiation factors.
They carefully examine the propellers, looking for evidence that might confirm suspicions raised by the FAA advisory. But it's another dead end.
We're able to determine all the blades were attached, and the bending that we saw was the expected pattern from proper operation when those blades hit the water.
Once again, they're back to square one.
This is what I want you to look at.
Investigators focus their attention on the fractured wing. They've noticed sooting on parts of it. It's evidence of a very rapid fire.
We want to find anything that could be the initiating factor for the wing separation. Could it have been a collision with an object? Could it have been a fire? Could it have actually been a criminal act?
The burn marks raise a sinister possibility. An explosion. A bomb. This now falls outside the NTSB's area of expertise and authority.
Let's notify the FBI.
The FBI helps us in many of our investigations, and we will utilize some of their experts to rule out terrorism or a criminal act.
If it was a bomb that brought down Flight 101, a likely target would have been one of the 18 passengers.
Thanks for coming in. We're going to need your help on this.
One name stands out on the passenger manifest: Sergio D'Angelicourt.
Welcome aboard. Can I see your boarding passes?
Certainly.
There are rumors on the internet that the crash was an assassination plot and D'Angelicourt was the target. His family made a fortune in pre-Castro Cuba. They were so opposed to Fidel Castro's regime that they had allegedly supported clandestine attempts to overthrow his communist government.
This is your copy? All right, now there's something I want to show you. We can't tell if it's just soot or it's explosive residue.
A bomb will leave chemical traces and distinctive patterns in the torn metal. FBI technicians are specially trained to detect them. The samples from the wreckage will be tested at FBI labs in Quantico, Virginia. Four days after the accident, salvage crews are still bringing in wing fragments found at the crash site.
So we need everything that looks like it come from the right wing. Can we get some light over here? Overstress.
Most of the damage they see is from overstress fractures, areas where the metal was literally ripped apart when the wing tore off.
Come here. That's the sink.
When metal is suddenly stressed to the point of breaking, the fracture leaves a very distinctive rough edge. It's easy to distinguish it from fractures that have developed slowly over time.
Cut this from here to here and get it to Clinton, Washington.
As we started to examine the right wing, spar and other components on scene at the Coast Guard station or the seaplane base, this was a visual examination there. We didn't have the sophisticated lab tools that we have at headquarters.
They identify parts to be shipped to the lab in Washington, where they hope closer inspection will reveal exactly what went wrong with the wing.
Hey, Clint. Clint, we're sending you as much of the wing as we have your way. Yeah, okay. Yeah, no, I'm still waiting for that report.
The results from the FBI explosives test come in.
Is that... Oh, yeah?
Yeah.
A mid-air bombing assassination could explain everything. But there is no explosive residue on the wreckage.
Okay, so that rules that out.
Structural failure is now the chief suspect in the downing of Chalk's Flight 101.
Well, that's all that's left. That's tomorrow.
It was obvious the airplane had a catastrophic structural failure. So we needed to find out the cause, the initiating factor of that structural failure.
He needs to know more about the long history of this particular Grumman Mallard.
It's very typical in any accident investigation. We want to look at the maintenance history of an aircraft. For an aircraft that's 60 years old, that's even more so important.
It takes days to comb through the 28 boxes of old records.
We want to make sure that we can develop an entire history of this aircraft, what sort of chronic problems may have shown up in the maintenance of the aircraft, and what types of work had been done on any of the factors that looked likely to be involved.
Clint Cruikshanks is a structures investigator for the NTSB.
When we go into an investigation, we try to go in with a very open mind and look at the wreckage and let it tell the story for what happened. We wanted to look at every piece that broke on the right wing to determine if this was a age-related failure or if it was something that was caused by a structural overload.
As with most aircraft, the Mallard's wings are built from aluminium alloy. The spars run the length of each wing. In between the spars are stringers that give added support. Together, these parts make up the wing box, which also doubles as a fuel tank.
And then the skin is over top of all of that structure to kind of give a smooth aerodynamic look to the wing. All of these together work to carry the flight loads that the wing is designed to carry. Once you compromise one piece of that structure, the ability to carry the normal flight loads has been compromised.
Thanks.
Over the years, the wing box had been repaired many times. Chalk's mechanics had patched up areas damaged by corrosion, which is not unusual for an aging aircraft, especially a seaplane.
The fact that they land on water means that their takeoff and landing loads are different than you would have on a land-based airplane. Also, they're always in water, and the corrosive effects of water are going to happen more readily on those airplanes.
But when investigators examine the rest of the Chalk's fleet, they find that the Mallards are in far worse shape than they imagined.
Corrosion repairs. Corrosion. 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 Corrosion repairs. Lots of them.
The accident airplane and the other airplanes in Chalk's fleet were rife with maintenance issues. Corrosion was rampant on all the airplanes. There was evidence of shoddy maintenance practices on all of their other airplanes.
Many of the repairs exhibited extremely poor workmanship in quality, double, triple drilling of holes, excessive grinding of corrosion, scars on the material. And this involved the structural repairs that were made to the aircraft over the past few years.
Cruikshank's attention is drawn to a section of the lower right wing. There is a metal patch called a doubler on the surface of the wing's skin.
A doubler is simply a sheet of metal that goes over top of the skin, and it acts as a load transfer. It acts as a second piece of skin to patch the crack. It's kind of like the patch on a pair of jeans.
This is a big repair job. You sure we don't have anything on this?
It's an intriguing discovery. The patch is located exactly where the wing broke off from the rest of the plane. When he takes a closer look at this section of the wing, Cruikshanks notices the edges are smooth and shiny, totally unlike the rough edges he's been seeing on other debris.
We gotta see what's under this.
This crack is not from overstress. Instead, Cruikshanks suspects it developed over many years as the result of metal fatigue.
Metal fatigue is the process by which any piece of metal, a wing spar or anything, is repetitively loaded and unloaded. You can think of it as bending a paperclip back and forth, and everyone's done this, and after a while, it eventually breaks.
Metal fatigue in the wings is caused by the stress of flight over the lifetime of the aircraft.
In the case of this aircraft, every time it took off, the wing is loaded. That's lift that gets the airplane up into the air. Every time it lands, the wing is now unloaded, and there's no more stress on the wing structure anymore. That's just like bending that paperclip back and forth.
Cruikshanks is eager to find out what's underneath the metal patch.
Okay, let's see what this doubler's hiding.
They find even more metal fatigue. Deep cracks cut across the wing. The extent of the damage is staggering. A crack 40 centimeters long.
Man, oh man.
Investigating further, Cruikshanks makes another disturbing find.
3 machined holes in the skin forward of the leading edge. All 3 appear to be stop drill holes.
The holes indicate that Chalk's mechanics had been trying to stop the crack from spreading further. Years earlier, a mechanic had spotted the crack on the lower surface of the wing. He repaired it by drilling a hole in the path of the crack. It's called a stop drill hole.
The end of a crack, you can see even with the naked eye, is sharp. It comes to a point. That tends to want to develop a crack more. By drilling a hole at the end of the crack, that would spread out the stress, and the idea is to stop the growth of the crack there.
But the stop drill holes didn't work.
An attempt was made to repair that skin on 3 different occasions by stop drilling.
Even as mechanics put in more holes, the crack kept growing.
After the 3rd stop drill, an attempt was made to further repair the wing by attaching doublers on the interior and exterior surface of the skin.
But the doublers didn't work either. The crack on the plane's skin continued to grow. Investigators now know the right wing was damaged long before the day of the accident. What they don't understand is why the crack could not be stopped.
Proved.
But a glimmer of an answer comes when they learn the plane was sending out warning signs of a deeper, more serious problem.
The Chalk's airplane involved in the accident were showing evidence of chronic fuel leaks for a long period of time, for many years.
According to the log, fuel leaks from the right wing were repaired again and again, but they kept happening.
The crews started to notice repeated fuel leaks during standard operations, and we tried to bring it up to the attention of management just for our concerns.
Just 2 days before the crash, it happened again. While doing routine maintenance on the Mallard, a mechanic came across fuel dripping from the right wing.
They always addressed the problem with trying to reseal the fuel tanks or trying to fix whatever problem they thought they had. It always seemed to be a reoccurring issue.
The procedure for plugging a leak was to apply a chemical sealant to the inside of the empty fuel tank. The sealant would take a day to dry. Then the plane could be refueled and returned to service. The leaks should have been a clue that the crack in the wing skin was just the tip of the iceberg. That there was a much more dangerous problem with the wing's interior structure.
Fuel leaks in this particular aircraft are indicative of a problem with the wing structure. In fact, Grumman put out a service bulletin back in 1963 that warned mechanics chronic fuel leaks are an indicator of a structural issue with the aircraft.
Okay, let's see what we got here.
Crookshanks examines the pieces that make up the right fuel tank.
Some kind of sealant.
He wonders why the fuel leaks persisted in spite of the constant efforts to repair them.
Hand me that scraper, please. Thank you.
Beneath the layers of sealant, he finds his answer.
Bingo.
Cracks in a critical support beam called a Z-stringer. It's the piece that the plane's skin was directly attached to.
All right, will you finish cleaning this off and then get some pictures, okay? Thank you.
Crookshanks finds evidence that Chalk's mechanics had tried to repair the stringer.
It appears that they did some grinding on the Z-stringer to remove a fatigue crack. However, they never went back in and re-inspected that area.
Instead, they only applied chemical sealant to the area to make it leak-proof, and in the process concealed the damage.
Chalk's made repeated attempts to repair the airplane by stop drilling the wing skin cracks, adding doublers over top of the cracks. But they never addressed the root of the problem, which is the cracked Z-stringer. The reason they couldn't address the Z-stringer is it was covered in fuel tank sealant.
The broken Z-stringer weakened the entire wing. Now, with every takeoff and landing, the plane's skin was absorbing the forces. Over time, the skin began to crack as well. The final outcome was inevitable.
The fatigue cracking reached critical length and the wing separated from the airplane.
Investigators conclude that a hidden crack in a key component of the right wing led to the devastating crash of Flight 101.
Go all the way up and down.
Chalk's failure to identify such a serious problem now forces investigators to re-examine the airline's long history. Chalk's Ocean Airways had an image as one of the safest airlines in the world. Despite the age of their fleet, the airline had an outstanding record of safety dating back almost 90 years.
Chalk's safety record was great. They had never lost a passenger in all the years of operation.
Chalk was an old, established company, but it seems to me that somewhere along the line, the management and the quality of the work done had slipped quite a bit from in the past years.
What have you got on the financial state of this company?
Investigators are beginning to suspect that the company's reputation for safety may have been undermined in recent years by money problems.
Financial issues in an airline, especially a small carrier like this, can manifest themselves in many ways. Personnel are sometimes one of the first things to go.
A search of Chalk's financial history uncovers some trouble. In the 1980s, Chalk's went through a string of owners before going bankrupt in 1999. The airline was revived by a Miami businessman, but it kept losing money. Just a few months before the crash, the last attempt to sell the business fell through.
Not doing so well.
It wasn't a secret that we were having financial difficulty. The pilots had taken pay cuts and the captains had taken concessions, and we downsized a lot as far as personnel.
It wasn't just personnel that felt the pinch.
It was difficult for Chalk's to find spare parts and to do some of their repairs. Chalk's had a number of other unflyable aircraft that they owned that they would cannibalize for spare parts.
There were maybe only 50 or 55 aircraft ever built. In that case, the original manufacturer, Grumman, was no longer in production of that aircraft. They no longer supplied parts.
The airline's deteriorating health and the shortage of spare parts had a direct impact on safety.
There's so much regulation and there's so much just necessity to make the airplane fly. It's hard to skimp on maintenance and not impact reliability. And if you don't have reliability, then you're just spiraling downhill.
But no matter how tight the finances were, as a commercial airline, Chalk's should have been closely monitored by the Federal Aviation Administration. In fact, the FAA did assign an inspector to work closely with Chalk's.
The FAA inspector, which is called a principal maintenance inspector, was responsible for the oversight of the maintenance program as carried out by Chalk.
The inspector was aware the plane was suffering from chronic fuel leaks. And yet, inexplicably, he gave Chalk's a clean bill of health just 2 months before the crash.
What was this guy doing?
Investigators are at a loss to explain why the FAA inspector didn't pick up on warning signs the Chalk seaplane was giving off.
fact that Chalk was an old established carrier. Maybe they just accepted, well, there's only 2 or 3 planes, it's a small operation, they only fly during the nice weathers, and they're good old boys over there, they know what they're doing.
In effect, the FAA didn't step back and take a look at that forest for the trees and find out just what's going on in the maintenance program with these Chalk's aircraft.
The FAA may not have found fault with Chalk's, but it turns out that several people very close to the airline did.
But we did talk to this group of pilots who had left Chalk's prior to the accident, and every single one of them did have some story about maintenance aspects on their aircraft, whether it had to do with fuel leaks or other maintenance aspects. They all had some level of concern about the way Chalk's was taking care of these very old airplanes.
In fact, the pilots were so concerned that in the year leading up to the crash, many of them met to discuss the problem of declining maintenance.
The captains of the company decided that it would be best for us to get together as a group, discuss the issues that we had to try to get our concerns addressed. One major issue that had happened, we had an elevator cable that had snapped in flight, and the crew luckily was able to get the airplane down using power and different settings and shifting people. But in most scenarios, that would have been an accident in itself. In aviation, there's error chains that they talk about, and you have to just, if you keep compiling one link after another, it's only a matter of time before an accident will occur. And from my point of view, I thought that if they kept going down the same road that they were going down, something could happen.
Eventually, Captain Weber decided he'd seen enough close calls.
My turning point and why I decided to leave Chalk's was I just had seen too many things in the recent months, too many mechanical issues that were major issues in my mind, and I had 3 engine failures myself that year, and I had a wife at home that was pregnant. I had lost, I guess, my confidence in the company's ability or the airplane, and I just had had enough.
The NTSB's report on the crash of Flight 101 harshly criticizes the FAA for not detecting growing maintenance and financial problems at Chalk's.
Had the maintenance program or the FAA stepped back and said, these aircraft need more than just a one-time fix. They need something much deeper than this, the accident probably would not have happened.
It also uncovers a loophole in the FAA's aging aircraft regulations, which require extra inspections for older planes. But those rules didn't apply to Mallards.
The Grumman Mallard was manufactured in 1947. It only carried 17 passengers, and it was not a transport category airplane. Therefore, it was exempt from these supplemental inspections. What we have here is the FAA has made an aging airplane safety rule, and they've exempted the oldest airplanes in the fleet.
The NTSB recommends that the FAA expand its oversight of aging planes.
When we determine the probable cause of an aircraft, the point is to do this so that similar accidents won't happen again in the future. I think we've used this accident to point towards the industry and the FAA to make sure that they take a look at the overall picture of what's going on at an air carrier.
Flight 101 spelled the end of Chalk's Ocean Airways. A few months after the report was released, the airline shut down.
There was a lot of history and a lot of family community involved with the passengers as well as the people in the airline. So to see the whole airline and everything else kind of go down with the airplane is additionally, emotional for everybody that ever worked there or ever loved the airplanes.